I went to Perimeter Institute, as you did a few years ago, or you went this summer, right? And I learned a whole bunch of things there. One of the activities was the one that you're going to do here, which is now modified a bit, so we'll see how that goes. The plan is for you to walk out of here feeling like you have something to take home and use. Okay, this is not about taking and ramming something down anybody's throat. Modify it, use it, don't use it, but hopefully you have a very good day today and you come out here feeling like you learned something. And if you didn't, that's, I guess, maybe the way it goes some days. But I'm just going to start, and maybe people can introduce themselves. Tell me your background a little bit, just to make sure that everybody's on the same comfortable page. This is your group. Like, these are your people. Like, right, look around. These are. I was telling Jen when she came here, I said, we teach on an island. Like, we are these little physics, chemistry geeks, and sometimes you fell into it by accident. Whether you did it or you didn't, we're always on these little islands, and sometimes we're scared to collaborate or reach out because we feel like maybe you're a bit, I'm not saying inferior, but you're so busy. Life is busy. So today is your day. So take and get as much as you can out of it, and hopefully you can use something, and it'll be hopefully a really good experience for yourself. And hopefully you can share, set up a network, and you can start passing and sharing things to one another. So Blair, I know Blair has been a long time teacher at SRE, so I'll let him start it off, and then we can go around a little bit, everybody can introduce themselves, and away we go.
All right, yeah, Blair Grader, I'm at SRE. I've been teaching for 20 years or so. I've got physical science, physics, health science, biology, science, calculus, pre-calculus. I've done environmental science before. So yeah, I've done some piloting work, I've done some development work for the ministry too, and was at Perimeter Institute in 2017, so kind of a real mixed bag.
2017, you went there as well, it's kind of close to that. So did you get as much excitement as I did out of that?
It was about 18 or 20 hours a day of learning fun, so it was pretty good.
So you're like I was
Yeah.
I'm Cindy Snurch. I teach at North Opposite School. I have taught Science 7, Science 8, Science 9, Science 10, Health Science 20, Physical Science 20, Chem 30, Bio 30, Physics 30, and various amounts of math courses as well. So,
And how many years? You said 15 years?
15 in Kenora Comp, but work now 6 or something like that in the senior sciences since Helen Forbes retired.
Right. Was that your first teaching gig 15 years ago, or you were in so much before that?
I was in Alberta prior.
Wow,
Yeah.
and did the same thing to science as that?
Yeah, well, you know how it is when you first start out of school. You get,
And there you go.
I honestly, if you were a social studies teacher anywhere in the country of Canada, about 20 minutes ago, you have your course built. Like, I don't know how in the world, I taught social as well, and English.
I'm Moran Chapman. I'm at Yorkton Regional right now. I was previously at Sturgis for 5 years, started in 2010. And mostly I've been teaching biology and health science, physical science, science 9, 10. And this year I'm teaching physics.
You want to tell us why? No? Nick Farmer. Yeah, first of all, thanks to Ron for suggesting this date when he brought it to me. I thought that's an amazing idea from an amazing resort site. If you think Ron looks old, I'm older probably, because we actually did our masters together. I used to pick him up in Melville, and we based our master's classes on the big Burger King menu. That's picked up Phil in Fort Collins also. We go way back, and I know his strengths and how much he brings to education. His passion for kids, his passion for subject area. So this will, I know, be an amazing day. He's put a lot of thought and effort into it. So if you can, give him all the engagement you possibly can. Otherwise, just I'm superintendent of education. This day is not about me, so I'll just pass it forward. Yeah.
I'm Megan Grover. I'm up at Sturgis. I'm from Lower and so I have the 7 to 12 sciences, and then I also get thrown some PA courses as well.
Does Priestville have different science, like Priestville at Sturgis?
Yeah.
Okay,
Yeah. Heidi was over in Sturgis for a little bit while I was on mat leave. So,
Okay, so then you have, are you accredited in physics and
not
science?
physics, but environment and chemistry. I guess.
Okay, so then you have to go to departmental.
Yes.
I'm Laura Ford. I've been teaching for about 20 years, but this is my first year doing science. I have done earlier science in the past, but I'm a phys ed major. But I am a passionate learner. So that is what I've been doing this year, is learning my assignment, which is Chem 30, Physics 30, Bio 30, Environmental 20, Health 20, Science 10, and Outdoor Leadership and Financial Literacy
So how many years in Lashburg?
10. This is my
Oh, this
first
is
year.
it?
Yeah.
Is this your
Yeah.
first year of teaching? Or, no.
No, I've been teaching about 20 years.
Oh,
I've
20
been
years,
in
and then now
physics.
you got senior science.
Yeah.
And you've been doing phys ed and social studies kind of
Yeah.
stuff.
So,
Wow. And where was home before Lashburg?
I've been commuting to Yorkton.
Okay, so you live in Yorkton?
No, I live in Lashburg.
Oh, but
But
you were
my
commuting
year-
to Yorkton?
Yeah.
Now you got a job in Lashburg?
Yeah.
And you're happy that you got a job in
And it
Lashburg?
was just a opportunity that came up. Obviously.
Yeah.
Like, do something different.
So I'm Donna Hamilton and I teach at preschool. I've been with GSSD 16 years, but this is my 31st year of teaching. I mainly teach the high school maths, but I also have been doing physics 30 throughout the whole 30 years, and also environmental science here and there. I have tried science twice, and I almost ended my career both times. So I'll stick with the high schoolers.
They're different paths, those young kids, there's no question about
It
it.
is, and they're impressed with everything.
My turn. Okay, I'm Jen Humphrey. I took over for Ron this year. I just transplanted from Ontario over the summer. So I've been teaching for about 10, 11 years now. I come from teaching basically like grade 11, grade 12 physics. We had hard school for us to start in grade 9, so I did grade 9, grade 10 science, math, anywhere from grade 9 to grade 12. I also taught the space science class that we ran as well. And yeah, Ron jokes about me having a wealth of knowledge. I did my master's degree in astrophysics, so I have a lot of admitted background in some of the stuff we're going to be going over today. So.
Okay.
I'm Kendra Helfrich. I'm a high school curriculum consultant. I've never taught physics. I barely took physics. I passed it, but that was about like my only goal. And I'm here mostly just because, partly because I think it's important to expand my comfort zone and to put myself outside of it every now and then, and to just get a better understanding of how I can support you all in your different roles and what that looks like. And then part of it also, I run the accreditation seminars with the STF, and so I come at that with sort of from the English humanities background, but we have anybody who's seeking accreditation in those seminars, so the more I can understand about the different subjects that people are there to get accredited in, the better off I'm able to facilitate those seminars. So thanks for letting me hang out for a little bit this morning, Ron, I appreciate it.
Absolutely. The more the merrier. The more people that can learn physics, the happier we'll be. But the more we learn, the better off all our kids in our division will be. Okay, so let's get into it. We're going to do, if you look at the package that you have in front of you, there's a very poor outline that I made, but we're going to more or less follow. Anybody knows me, I don't actually follow much of an outline. But we're going to get into Planck's constant. This is the one I sent you the results on. That I have a color version of in a little bit. But we are going to quantize light. And here's a quick little physics. I'm not sure your knowledge, and so please ask away, because that's what part of your experience is here a little bit. But what we're going to do is we're going to take a little LED, and we're going to put a little bit of energy across it, and it's going to fire a photon of light across it. That's what we're going to do. So we have these little sets right here. And by the way, when you leave here, you will leave with a little set, because I actually bought sets for everybody. with makes money. Okay? So we have sets for everybody, and these guys come in all the wavelengths of light. Okay, so they come from red to blue to UV to some random like pink and some other ones that have some blend of light in them anyways. And so we're going to use these guys right here. They're about between 2 to 3 volts. And so we're going to get into little groups here in a bit. But the idea is we're going to send a photon of light across this little LED. Okay? That's what we're going to do. And then it's going to light up and we're going to be able to see it. Okay? And so from there, we're going to measure something called Planck's constant. And so the idea is, just to get you going a little bit, is the higher the frequency, the higher the energy. So like a red light, like Roy G. Biv, okay, is that looking good? Okay, so red's going to have a lower energy, and then the blues, the greens, the violets are going to have a higher energy, and then we're going to fire one photon across this thing. Okay, so that's what we're going to do. And you're going to be able to measure that, we're going to be able to graph it, and we're going to be able to get Planck's constant under 10%. That's going to be our goal. Okay? I always think if you do something, you get under 10%. You could get these fancy pedometers, and you could do some more accurate stuff, and we could get it with about 1 or 2% if you really, really wanted to. But Perimeter doesn't send these out anymore. You have some. Okay? Okay? And maybe some people have some of these little kits, which is basically we're trying to do it so anybody can do this activity anywhere. All you have to do, and these sets are like basically they're like $14. Okay, so you have basically no equipment. There's a calculator on the table that's only to measure the energy or the potential difference across this. These little things have a long, which one did I grab this out of? We're going to find out. There's a long one and a short little terminal on these things, and that becomes important if you look at the diagram. Hopefully I labeled the diagram not bad. All this stuff, I'll show you where to access it. This is all on a Google Doc, and so you can change it, you can modify it, you can do whatever you want with it. You can pitch it in the garbage, okay, when you leave, okay? And that's fine as well, okay? Because not everything is useful to where you are at your stage of your life in your teaching. But that's what we're doing. We're going to do 2 activities this morning. One, we're going to do Planck's constant, okay? And we're going to graph it. We're going to go through the whole thing so that you have your shovel ready. You can take this, you can use it tomorrow, okay? That's the idea. Okay, you'll have the resources of everything that you need besides maybe some batteries. Okay, then we're going to do the particle zoo activity, and we might watch a short little video, possibly, if you've never seen that little video from Perimeter Institute. And then we're going to have lunch, and then we're going to do some assessment, and then hopefully we can do some sharing. You can tell me all the great stuff. And if we don't have much to share, we'll pull out some radioactive rocks, and we'll test for some alpha and beta and gamma radiation, and we'll see how that goes. Okay? And so that'll be our backup plan if you want to do that, or there's other activities that we could do, and we could go there. Or you could share, of course, anything. Because, of course, this is your day, okay? So this is all about you, and if it's about me, that's the wrong person, okay? So let's make it about you and not about me, okay? So let's go through the activity a little bit and just give you a rough idea what's happening. I know you're all intelligent people, and so you can read, unlike probably most grade 12s, okay, where you have to tell them everything. So there are somewhat instructions. All this is from Perimeter Institute. I do have the original document. I modified it, as I most of the time do with labs that I have for equipment. So I take it and I put it into a digital form that I can actually change and modify. But basically what you are doing is you're going to take 2 AA batteries. You can see this, okay, hopefully, okay? And you are going to put some rolled up Play-Doh between them. You are going to put a couple of copper wires into here and then hook it to with these little alligator clamps. So it's kind of going to look something like this. You're going to have this stuck into a little roll of Play-Doh, and by the way, I have a whole box of Play-Doh I bought. So if you don't have Play-Doh, you can take some Play-Doh home. You're going to hook this Play-Doh into here. See, it's the same color. Okay? And then you're going to hook the clip onto here, and then that little clip is going to go onto the LED. LED should light, okay, once we hook up both sides. The only reason you need the wire is because it's kind of a pain. You could just stick the clip in there as well if you wanted to, and that would be fine as well. I mean, you would probably have a connection. I tried with various thicknesses and lengths of Play-Doh, to me, it didn't make a whole lot of difference. So I tried having this really long, I tried having it short, I tried having it really fat. Results seem to be about the same results, okay? And so we're gonna hook this up and we're gonna get some results. Okay, but before we do that, we have to learn how to use this little machine right here. So what I need you to do is get with a partner or 3 people and get beside a machine that has a Play-Doh on it, and you can move around, and I'll show you how to work that machine.
So we've got 1, 2, we have 3 setups. So
You should have 4.
4, where did you put the 4?
But
Oh
I
yeah,
mean-
the 4th ones are here.
Yep. There is 4.
4.
Okay.
So, yeah, we got a 4 over here. Yeah. More kids in my group. It's always fun to so fresh Play-Doh.
Yes, the Russian Play-Doh is just fun. Everything else
Yeah, I saw the
Okay,
water
so-
and then I almost hit him.
If you've never used this calculator, needs to be plugged in, or some of you have no adapter and there needs to be a battery added to the back. Okay, so we have to. Okay, and when you plug it in, it should make a little beep 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 sound for you. And just give it a second. So you hear that beeping? That's a good sign. Okay? Perfect. That's what happens. You have to add the battery. You have to add the AA battery to the back of it. Put in the back of this part right here. Okay? Just make sure your calculator turns on and you have it working. Yours probably was working, I think. Okay, so you're probably okay. Okay, guys, are ready? Let's just make sure we know how to use this thing first, then we can build. Okay? So, if you have this calculator, yeah, don't worry if it says low battery, but go to apps. Okay, just click on the app button, it's a little pink app button. You have to get it so that you can read. We're just going to test your batteries first, okay? Make sure you have good batteries. Okay, and just go all the way down to where you have to just use the arrow key, and you're looking for a program called Datamate. Okay, now by the way, you don't need this. You can use any basically voltmeter would work as well. Any multimeter would work. This is just what we have here. Once it starts, you should get a reading. If it says 999, okay, like mine does, then just go clear and it should clear it up and it should read 0. No, just make sure they're all reading 0. Mine's reading about 0, reading 0. Okay, we're just going to clear it. You just got to reset it. Is yours reading 0? Okay.
I'm gonna grab the setup and set it up the other way.
Sure. That's my 9-volt battery for you then. But yeah, it's working. Okay, is yours on, you guys?
We're getting there.
Okay.
There we go. Nice and neat.
Yeah, it's the beat that we wanted, yeah. Okay, now while you're sitting there, test one of your batteries out. Just push on the little, these little ends here. They're great because they got little stickies on them like this. Just push on each one and test your 2 batteries and make sure they're reading. Okay, put the positive to the positive. Positive is red, negative is here, and to see if it reads, hopefully about 1.5 or 1.6.
Still saying negative 9.0.
Mine reading 1.64 on my Duracell. What are you getting? Are you getting a? Okay, now push on it. You gotta push on these little ends right here just to get the metal out. Okay. Okay. Can you get a reading?
Is that just the?
No. Okay. No, you gotta get a full. You should get a full reading of. Unless these batteries are chopped zero from the bargain store. We'll get batteries. 1.6. There you go. Okay. Yeah, you just gotta touch them so that they're touching on the end. Okay.
No, I go too far.
Oh no, you gotta use Easy Data on that one.
Okay.
Yeah, that one's just got a different program. It'll read. Okay, is that one working? Okay, so you got that set up. Okay. How are you doing? You got it working? Oh, hang on, no, you just got it clear.
Okay.
It's just because I had it up before, this has to reread the sensor.
Now, do we have, just based on what's happening, like the traditional like multimeter voltmeters, or is this what I'm gonna be? Because I don't remember.
You have just old archaic ones. Yeah, like the old, like they're, big old meters,
Oh,
like
like
they're,
the
like they're,
big
no,
ones?
no, you have that too.
Yeah, I
You
was
like
like,
you know.
cookie those.
Okay, so, everybody's just working? Okay, so now you can make your, you can make up your little series circuit. Okay, so just take your Play-Doh, roll it into about the same size as the batteries are, and make 3 of those. So just hook them up.
We've got adaptations for everybody.
Absolutely. Okay?
Did it need to be the same size as each other?
By all means, if you've done this before and then you want to adapt it or do something, remember, it's your day to learn something. So just make yourself a little Play-Doh series circuit on it. I just shoved something on each side, like that.
Well, yeah, and I used to have like the battery pack with the cases.
Now, what you can do, just to make sure that you have a circuit, just test it out. Make sure you got positive to negative, and then just, you can hook this on just to make sure that you have a circuit, that you have it all connected.
Yes, I do.
You should get a reading around 3 volts, more or less. Yeah, just stick it in there.
So
You got a reading of about 3?
at home, I would do placeholders for the alligator. Because the way
batteries,
that
like
I set this
1.6?
one up is instead of
Try it
having
again.
his setup,
You get
I
batteries
do
in for you.
yeah,
Yeah,
LED.
100%, for sure, but the fact that we've got.
So it's just a slightly different thing.
One battery.
I was serious, I was wondering about that.
Well, because
The Play-Doh is cheap now too,
Right.
which is great, because those little fancy other ones, if you put them on the bathrooms,
You should have.
they fry, and it smells like burn. I know
We gotta get a
this.
little
Yeah.
more.
Yeah.
Check about 3. What do you get?
There we go, keep going.
What do you get for that?
Yeah, between us.
Maybe.
since I
We
was
were short of it.
Possible.
You also could just swap it out.
No, I'm getting the 2.
Yeah, I'm not getting very much either.
Try these batteries, just I'm curious. What are you getting when you do yours?
I'm not very.
Yeah, so that's, wow.
It's pretty cool setup.
Try these ones, just see if you get any difference.
So there is no appreciable difference.
Maybe a little bit. It shouldn't matter. Try to do smaller.
Round 2.
What do you get?
Right?
We're at 2?
Leave this
Okay, so hopefully that's
for
where
hours,
we need to be then. Okay, so we need about 1.7 or so to get that one lit up. Okay. Okay, paper. Yeah, that works. Let's take that down.
That is a huge loss.
What are you getting there?
Wow. Oh no, we're just looking at how much loss there is from having Play-Doh.
And what do you
Think
get?
about half a volt even just here.
Yeah.
Like in terms
Okay,
of. just
maybe
like
go
the
with
drop.
smaller rolls of Play-Doh than if it's too much of a drop.
Yeah, we were noticing the drop of potentially almost like a battery once you had all 3 pieces in.
Well, is the purple Play-Doh different than the other color Play-Doh? See, I never tried a different color Play-Doh.
Yeah, 0.5 volts each.
Yeah,
each
0.5 volts for each chunk of Play-Doh.
0.5.
Yeah, so by the time we put in 3 chunks of Play-Doh, we're.
But I'm getting
down with
around,
battery.
but I'm getting around 3.
Purple, I got more solid.
Awesome. Who knows? But
Wouldn't that be something?
that's wild, like in terms of the difference. Because yeah, we have 2 chunks of Play-Doh in here, and we are reading at about 2 volts.
But you know, these wires will drop about 0.1.
100%.
Right,
Here,
so-
what if we clip this shorter?
I'm getting 2.9 with my purple Play-Doh.
Wow.
You know what?
Because again, you and I both know, right? The more wire there is.
But you said as long as you get 1.6 volts, right?
Hey, hey, is that, you guys have neon Play-Doh? Is that the difference?
Who knows? But yes, we can all have neon
You
Play-Doh.
guys all have neon
Different
Play-Doh.
color?
Well, I'm
which
curious.
would be admittedly the fun of
Here.
science.
Okay, let's try here. I'll give you a non-neon color
That would
Play-Doh.
be hilarious, I'm not gonna lie.
Well, that would be
funny.
That would be a factor that I never thought of.
It might not be salty.
Yeah, I think that's one you and I chatted about this morning, but.
Well, I was saying it, but I was saying it kind of just jokingly. But yours isn't neon.
I actually bought some primary wires,
That's pretty good,
yeah. Connectors, but.
Can hold it.
It
Contains wheat.
Should be okay
I
then.
think they all do.
But still,
So interesting.
I'm curious if that neon Play-Doh makes a difference. Because look at the chunks I have. Like, they're pretty significant.
Yeah.
When I try different chunks, but I didn't try different colors.
That's true.
Your
Interesting.
chunks are fairly short in length compared to ours, so.
That's true.
A little less, but
Still a good
You
chunk.
still have a.
still about half of what we're
I
finding.
lost about half across the whole thing.
We're losing about half per piece.
Yeah.
Or half per piece.
You got Duracell batteries, we got e-circuit batteries,
They
so.
used to play this game.
Who knows?
Is there any difference if we take these batteries and these ones?
Who knows?
They would join hands.
Like, I love science. When I say that, I was like, we did circuits in science and
Yeah.
material too.
Well, once you get a stable reading of, I would assume you need at least over 2,
That would make some sense.
okay?
See if already
Does it need-
batteries.
Okay. Now what we're gonna do is, we're gonna hook up our lights. Okay, now, because they're sitting here, I'm gonna turn this the other way. I believe it's sitting like this. This is red, yellow, that's the white, which you don't need. Here's blue and green, orange, and the UV you can do.
I'm okay with that.
Okay?
I'm okay with the third one.
Okay? If you could try and put them back in the same place, that would be appreciated. Okay? So you can try and hook up each. Well, that's why I would make up little sets, and they wouldn't really matter. They could tell the color. That's a color blind. Yeah, like
one of each.
yeah, like when I give them, I would give them a little set like this, and they would have each color in there, right?
Yeah.
So it wouldn't matter, but I mean here, I mean it doesn't matter. It's just that.
It's dropping.
So what are you getting this time?
Oh no, we hooked up more batteries.
Of course, that's what you.
We're just like what the kids do. Steal batteries from
Well,
the
and then the kids go with the LED and.
Do you have a color preference?
Yes, but that's why we need this around 3 volts.
Yeah.
Because otherwise we will fry the LEDs. Okay, so as long as you have in that over 2 range, you're probably okay.
We're good. That's what's on.
That's perfect.
It's because I hooked it right into the Play-Doh.
Okay,
Like, alright.
so now we want.
We want LED. Yep.
Hey, you just do it for fun. Why not? This is all about, right? Okay, there's your reds, and then your, yeah, this is your red, this is your yellow, this is your white, that's your blue, your green. So you need your red, you need your yellow, okay? How you doing now?
That makes sense. The problem is makes sense.
I think that one's red.
So I would
Do you
use
have a straw?
battery holders here to take away the,
Oh,
like a little, like
Yeah, yes, 'cause
one of those little electrical sets.
or just put more batteries together.
Or put more batteries together.
Just one more? Have a whole bunch of them. Or else, there might be a 9 volt sitting here, but I don't know. As long as you, when you get the 9 volt, as long as you're under,
No, it's at 0.0.
but no, the way you're doing it, well, you still be able to test it though.
Yeah. I'm just curious.
Pause
now, I'm like,
oh.
And if you hook it up wrong, it's just not gonna happen.
I'm curious how that.
I was actually thinking.
Is this, you just hook it straight up,
Yeah, but you'll be able to test.
you skip all of the.
Yes, for sure. Yes, and that's how,
Personally, I've done it.
when I did it like that, I did it exactly like that. I fried my LEDs.
I was
Did you?
with Johnny
Yeah,
yesterday.
but then I was
shut off the
using
vehicle, be like,
maybe not a neon Play-Doh. Like it had, one had more resistance than the other one.
Well, we'll see, I'll try not to fry the LED.
Well, we got more LEDs. You know, if we're gonna try it, today's a good day,
Right.
right?
Jeez, we
Okay.
get stuck in Regina.
I don't.
You know, it's like, how can you go or what, right?
Yeah.
Because there's a fairly good value.
Right on to the
Oh,
thing.
like that.
Yeah, just clip it on. Just clip it on. Yeah, now just let it stabilize. And you should get a color light. See, is that red?
Yeah.
See? You got 1.59. Record that. Yeah, and it's stabilizing, right? Yeah. Yeah.
Okay.
Yeah,
You might be
probably
short
go
of
down a
that.
little bit less than that. Yeah, I would say if you can get down to that 2 range, keep it around the 2. You stick it here, where is it?
Yeah, no, it's very faint.
Oh,
it's too bright.
So it's about
I think so.
0.02.
Just do it behind it.
Because if you look carefully, like you can see that it's lit, or it was lit.
We'll see what happens. As long as it's got enough energy to light the bulb.
Oh, maybe because I.
The only one you might, when you get to the
Because
EV
it's
one,
not lit.
hopefully it'll go on, but you can still get your draw.
Okay,
Yeah, and if it doesn't, you'll just try it with 3 then. What is your?
so now I've got it.
Yeah.
You do?
Yeah.
Okay.
So, just poking, right?
Yeah, you just
So you poke,
Yeah.
poke and it's very bright.
Yeah, of course, yeah, and then you got more
For
then.
lack thereof. But yeah, this is where.
It goes light, it goes light. It doesn't work there.
Doesn't work.
Or
So now you gotta find.
Oh, no, oh,
In the
oh,
LED.
hang on.
Here, I'll give you that.
Okay, that's it, okay. No, go ahead.
So I wanna find it when it exactly, so that's very faint,
That's
right?
probably
There
so.
you go, there you
Just
So that is red.
So 1.64. That's almost the same number they're getting.
Yeah,
So they got 1.59.
Right.
And then you got 1.64.
Yeah.
So you're with,
Where you're
so,
here.
well, they're doing, she's doing the way the perimeter set to set it up.
See, and I
then
have
you
those
can
dials,
see
and I
play away and
always
see
like
how
Right.
much
try to.
lower.
well, but the trick is to just kind of be very gentle with them.
Yeah.
Like when
I
they-
try, Cindy. I really try.
Yeah.
I don't know what you want. I can be as gentle as I want, but something.
Yeah, they touch each other.
They touch each other.
So that's the thing. So that's
So
why when I
that's
saw
when
this
they-
one,
With the red.
because basically, especially when you're playing
So
with
the shaders
two
just uses
double A
it.
batteries,
Yes.
even the 9 volts,
Yeah.
if you get it too high,
It's a
then you
little
get
bit
the
on
LEDs
resistor, I guess.
size LED.
Yeah.
Well, yeah, but
Because
it.
you're over it, right?
Right.
But I mean, as long as you're probably here, you're okay, right?
Yeah.
Because you're probably not, you got thick enough,
Start with.
and maybe that was my problem, maybe I just didn't have it long and thick enough.
Yeah.
Yeah, but that's how it's supposed to work. So there was obviously enough resistance in it that it worked.
And I like this because it gives kids a very visual.
Of what the,
Of what it does.
Higher frequencies.
Good.
624, and then I always say, okay, like, you know,
Yeah. So do all of them and see what you can get for value.
okay, I'll report.
Okay, so what are we doing?
Something went off here.
This is like manual dexterity to the next degree, eh?
Well, it's just the connection.
Oh, I think we had something that's on a different one, but it's not just
Let's see
LED.
if the LED will work.
Is there, okay.
Where's our LED? Okay, we got the, okay, this is bend these,
Okay,
okay?
okay.
Okay, and then now it should go
Stick
on.
that.
Oh, it's going 1.7,
It
but it's
should-
not enough to
You'll
load
just
it.
take this one
Put
off.
the LED right into the plate
Station light
on
bulbs.
the side there,
Yeah,
and
see.
then just jump rid
See
of
the
the
red
black.
in there now.
You
Just
can?
one on the side of the LED.
Oh, wow, you got better eyes. Oh, yeah, you
Yeah,
can.
one
Let
there.
me,
Four hands, you're trying
I know.
to.
so now just take it this way.
Let's go.
And it doesn't, you don't have to have this fancy moment, you're just gonna go like this, we're just gonna put it across here, okay? Because it has to be across here, because this is where the power is. Okay, so you're 1.57, see, 1.565, 1.57? Okay, which is pretty good, because they got 1.58, they got 1.64, so you're good. Now, we might get into trouble if we don't have enough power when we do the other one, if we can't light up the third one.
What's the next?
But I don't know why, but I wonder if we had,
Wait per se?
if we just went a little bit skinnier in these.
Is it 1 point?
Or,
Should be able
in
to
the
get
case of,
juice out of these things.
the kids quote something out, right? And
Mm-hmm.
if they tell you,
Yeah.
all right, replace it, but if you
No,
don't.
no, it's a reading positive, like 1 to 0.
So we reverse the
I
the
reversed
bias
it
in
and
the
then.
diode and that will, yeah.
Right? Let's try it again, see if that makes any difference in the. No, no, it doesn't.
I think you're just, oh shoot, I lost it. There was just a little glow out of
Any
there.
difference?
Oh, yeah, there it is.
No,
You're right across it.
yeah, there's a little bit there. So that's actually a really good, get started too.
Yeah, or.
See, 1.6. Yeah. But see, but it didn't change a whole lot. See, that didn't, you know, you talk 1.57, 1.6. So depending on how accurate your machine is,
Teaching physics?
you know.
You're
let's see
in
about
No,
one.
next semester.
That is EMF.
Oh, the
That's-
EMF.
Yeah, that's why.
We'll look up the wavelengths
It
after.
is literally going to just be learned.
Yeah.
This is what I've been doing with
I'm having a hard
Does
time.
it need anything else?
I swear, it,
Yeah, but you might have too much.
Well, we had me somewhere.
Well, yeah, I
yeah,
created the
yeah.
verb.
It's just hard to see from.
Oh, but
It's
that's
about for the
too.
discount.
We had it at 1.7 before.
So I don't
It was
understand,
hard to
like,
see
do you
because
have
the yellow's not
bio
lighting up very well.
semester
Yeah,
too?
but
No, I'm doing
You
bio
can't
now.
change it once you have your energy, you don't
Yeah, yeah,
change it.
Yeah.
So I would go
Bio's
with
fine,
the.
'cause I did.
We were
I did
we
start
were just
with
trying to see what we
general.
get.
Well, I'm physics.
Yeah.
like.
Kind of biology.
Physiology
Yeah,
of
but
all
you want it
Yes.
barely.
Yes.
You want, yeah, you want
Not
it barely
that.
let you just get that one
Yes.
photon, yeah?
Go on.
And then once you
I
get
get
that
a
kind of
second
established,
slide.
that power range, then you can
But the
do
count
all of
is,
them, right? No, it's
And
not,
they're
there's no
in
contact.
departmental.
Yes.
Oh, no, oh, sorry, you
Yes.
don't have
That's
a,
my-
We were trying, because we were having trouble keeping all the wires
Is
connected
We
nicely.
gotta get this done.
Oh,
Yeah.
you need to
Gotta
make
get
it
it
up?
done right.
Like you can't
And
connect it
so
this way,
it is a
though.
lot of textbook work and a lot of fun.
But that's okay.
Oh.
But you know what,
Yes,
when
no,
you're
when you're
actually doing this, like, that's
You
what
got- you got
everybody
it.
does.
Okay.
Teacher resource
You had
manual,
it before,
textbooks,
and
because it's
Which
survival.
should be the
And
rate
then
zero,
once you've done it
because you
again, then it's
can't
like, okay,
read
now
it.
I can start
use
to
potential
write
without
some other
creating
things,
it.
But it takes a
You
while.
don't use what you have.
Hey, so do each of your lights,
understand.
But we
But
did
it's-
have.
yeah,
Thankfully.
Yeah.
I know, I was like, wait, no.
Yeah, it's just to get myself to the point where, the other thing is I don't understand why they don't
I would,
understand.
I'd just
Right,
look at the
like,
other
sort of-
users and then use these
I
two
can't-
guys and jump
Well, the
across
biggest
it.
thing is you have to assume that they come in with good hair. Because they do,
Yeah.
right? Like, even if they've done
Because it
different
doesn't-
science, business, science 20, like, they don't transfer those skills.
No.
Like, I feel like, okay, so I'm starting
So
physical
it's
science
using
20,
Play-Doh.
a group of grade 11s here.
Make it
Yeah.
Claudia, did you get yours?
Yeah, we're just talking.
That's fine,
Oh, wait,
that's what this is
so-
about.
Sorry.
If you're learning something,
Let's
it's
do
great.
this. Oh, we're doing circuits.
Isn't that what it's all about, though?
Right, but-
So Cindy, you're at Kenora, you said?
Yeah, Kenora Hall, yeah.
So you're Derek's and Daphne is your boss.
Yeah.
Yeah, like you just jump across.
Yep,
I used
he
to train
is.
him.
Yeah, just get it lit up and then.
And you should be getting a higher
Yeah.
reading as you get a higher wavelength. Sorry, a higher
Play
frequency.
in my class.
A smaller wavelength.
Alright,
Which
of
color is
course,
that?
we're covering, we're gonna come back today, and I just throw all of our stuff that I possibly.
What was the other?
Go with that. Play with it.
Want to turn it up?
What does,
Are we getting it?
what do you mean?
Well, because, yeah, like if you want to
Ah.
micromanage. and you
Oh, is
wanna-
that what he did?
Yeah.
It's very
And you want
flexible.
to micromanage.
It was more of a flicker.
Yeah.
People wonder why I don't go to the rink anymore after I was done with college.
We're not getting any reading. It's negative 0.667.
Oh, come on.
You are saying keep turning
Oh,
off.
We're okay, it's on. We
Well,
gotta
I'm
break
just,
it.
I just, I'm like.
Let's do that red one.
Process, I
And then
want to
finish it.
finish it.
Let's do it,
Yeah.
yeah, well,
Yeah,
we
that
got
was
to change
changed
your
it, right?
verse,
No, red will
but
be.
save a number, right? Like if the kids, I always
Break
tell
that
them
one
to take
down.
whatever you get.
Yeah.
So we'll put that.
You should go higher as we're going higher, because we're getting higher
I
frequency.
just have
Yeah.
a different setup that I learned.
So here's the
I wonder if we should clear this
We're
again.
using the same.
It's actually, we'll leave it there, but you see the problem, this is probably your error. It's reading
I'm
point
not fond of
03.
this.
We're gonna calculate the energy.
No, I'm not.
And the frequency.
And I'm in a,
Yep.
so,
And
so
then we
let's-
should see that because it uses that
you could try
higher
it, but let's just.
Well,
You go. Is this working fairly good?
I think so.
You do the red one.
sometimes we're getting numbers.
See what
But
the
there
red
should
one
be a
reads.
point whereby we don't let these guys.
This is
out.
the,
Or.
this is the long side.
they're dimming.
Oh, it's good.
Well, that was the red.
No, no, I know. I put them together.
So it's
I'm getting it.
Graphically
is. Why would you do that though? Why would you not put them in terms of their wavelength or their frequency, right?
Right, yeah, anyways.
What are we getting?
And the green is out of.
Pretty decent results, but I have to do the percent.
Yeah.
Suggest what's going on, I should be further
And then it's
along my
combination.
path here this time.
That
This
will allow us
is
to get H.
like me, like you just wanna see what the results are,
So
right?
should we
Yeah.
be able to do
Not getting
it
a
now?
reading it.
Would be H.
Oh, we don't have them on, you're just looking for the light.
Yeah,
Yeah, I got
I
some.
want like the barely, oh no, I got it, it's on.
F is increasing.
Because I want it to be barely on.
Well, no, because I'm thinking
And I'm not
graphically,
fond of
the voltage potential, well, there's a voltage drop, right?
There you go. Now he's bringing it out.
Right,
But we should be using more voltage.
Thank you.
So like the higher frequencies, yes. because we need more energy to light them.
So I wonder if the key for this one
Because I was.
is to make sure you have enough thick Play-Doh. Like, use the whole bucket, in other words, right? Use that whole little bucket and
But
make
that's
sure.
what that perimeter handout says, it has an illustration exactly like this.
Frequency, so yeah, so frequency goes up.
They don't understand something.
Delta V.
Yes, that's how the setup was, exactly like what you were doing.
Yeah.
And then I did the first time, I must have just maybe got unlucky when I tried it.
We're not changing.
Maybe, or
Sorry.
they leave it for too long here,
No.
right? Like I would tell
I think I
Yeah,
had
one point three something.
So what do we need?
an inch too short of a thing. I think
Okay.
I'd have like
1.7.
this.
Oh, okay. So
Well, about the size,
the whole bucket.
about the whole bucket. The whole bucket, because I was getting too much power coming
Yeah,
out of it.
yeah, and
And
then
then
these little guys can only handle so much before they.
there you go,
Yeah.
yes.
So that's.
So
fair.
that works. You should
So
show
if we
me
don't
that.
change
That's
that,
definitely a good
on
setup.
some of these more
Well, and then if
saturated
you tell
colors,
kids
doing?
that, start.
needs more energy, essentially, does it just mean we won't be able to
Okay, so
light
oh, we got a reading.
at some point?
Okay, so there's the blue one. And then this one's a green one, my other hand. Just sweet.
There we go.
Well, they're
Oh,
light.
1.58 again. Yeah, let's write it down and let's see what the next color does. Let's do the yellow one again. Got the yellow one still there?
That one.
Okay, let's do the yellow one. Pop it off.
Do you want me to just go with
Actually,
different
you
roll?
can even cheat with this a little bit. I'll show you something to do it way faster, okay? We can actually hook this on here. Okay, and then we can actually touch them if we get
This is always the final step.
far enough.
The connections are basically
You
what
just put
wants
them on,
any of
right?
this frame.
And you don't have to, right there, see that spot right there?
Always.
Clip it right there.
Oh, that's lit nicely.
And you can just
Like,
actually
very
really fast.
clearly
You do
lit.
that one, then all you do is clip on the.
Ah, there we go. Bigger jump. Yep, no, we got a bigger number.
Yeah, just
But
push it down a bit, and
does
then
it-
clip that one
is it
back.
still lit right now?
No, it went off.
And
So that's.
Yeah.
We got it.
that.
No, it was
So
going
it's
off.
lit right now?
It's lit right now.
Fast now.
If I do that,
So,
Okay,
So
so
what
you
do I
want
do
to
now?
because you were touching the, no, because you were touching the LED directly as opposed to the alligator clip.
Well, that's weird.
But you have a section for other,
Yeah.
so then that
And
would
then
give you
other?
kind of.
Do we have other preference?
Whatever color.
well, I got something, I got 1.9.
Well, the one I did is I did that,
It's on right now, yeah. But when you're touching it, it's.
I did that.
This one is going on. So this.
I did that turquoise one when I did my other one.
Oh, did you?
Agreed.
Yeah, and the turquoise one fit right in
It was
the
going around.
band where it should fit,
Okay.
between green and yellow.
Okay.
It actually gave me the right frequency.
Probably just draining the battery. 6, 7.
It's between that and chartreuse.
It still is lit?
Well, neither is church
Chartreuse is turquoise and kind of work. It's actually yellowy green. So it's
Interesting.
So there shouldn't be basically
Yeah.
any current
It's
going
actually
through
passions on
here.
there.
Not right now, no. And in general, right, it's just.
And when we test it, it should have a really high current resistance, so all of the electricity should be measuring the potential,
Mhm.
so it shouldn't short out.
So here it is on right now.
Oh, those are good results. Those are fantastic.
So it does turn on, but I can see that
I think you're gonna be high.
it's not touching right now.
Yeah.
Yeah, as soon as you touch it,
Interesting.
But again,
Well,
So-
why would you be high?
because I'm probably.
Because for a split second, we got a reading of about
counting the lights
2.1.
Too much, right? Like, I should
I
have
know,
gone.
I understand that part,
Mhm.
but if you look high,
See, it
You
turns
should
the
be
light off, which is
double
why
times
it
constant.
goes back up.
not like 10%
Oh, no, maybe
higher.
it's a reflection.
Additional photons of light,
Maybe it was a reflection.
not 1.3 photons. It's not,
Right.
it's not possible in terms of the whole
No,
idea.
no, no, yeah, yeah, no, no,
Right,
there
right.
has to be a whole number here.
Right, so that's why I could never figure that out, like, I mean, you go down to the one, whatever it is.
Yes.
You
yeah.
could either have one,
Okay.
Or-
Right.
or do you have one with a higher energy and it's brighter, it shouldn't.
Yes.
The only thing that I can't.
We'll look this up, or you can look at this. I know you have those. I know, but that's, I know.
No,
but
this
that
boggles
wasn't
my
my
mind. You're
assumption.
like, wait a second, this shouldn't be happening.
Like to look up the.
Because the only time the light should
Or,
go
yeah,
off,
wait, like,
off is
or
to disrupt the
frequency, pick one.
connection.
Yeah.
Hey, if you are done and you got your values,
This is for measuring, we're
Okay.
changing the output.
set,
We're breaking physics.
We change the outcome, so.
Yes, well, that's true, though, yes, that's.
Well, no, we're breaking physics in the sense that our LEDs are turning off every time we try to measure.
Our voltmeter is shorting out instead of measuring the temperature.
You got a few readings?
Let's try the green one.
I like this one.
You like that one?
That's bizarre. I'm just like, hey, let's try a different one and see if it makes any
Yes.
difference.
I
This
also
will be a
like
lower.
that. Put the batteries.
This will be a lower.
This one should be, this one's actually higher than I think it should be, but we'll see.
Okay. And then just did
Once you get, I mean, you don't have to do a few, you can do the green one and then just do.
Did you use the copper
Yeah.
or straight into it?
Oh, I
Should
just
be
used a
higher.
paperclip.
I don't know why we do that.
There we go.
It's 1.58.
So I'm reducing the amount of,
As you said, we haven't changed.
Yeah,
our
with a,
Right.
yeah,
so.
connection.
Yeah, the green one's lit.
Whose energy is that?
so you know what?
I really don't. You should have
I'm
maybe
just
had
gonna
the
see
extra
how
battery
close.
filled after that.
So 1.624.
See, but there it is, 1.64.
So my numbers are higher, and I'm wondering if I was just going so fast
Right, obviously if we're wonking our
that
data
I
just to
was.
do this, but.
Okay, now we
But if
definitely.
there's using
So
less
now let's
energy
see
with
what
your
happens.
system, that,
Is it actually?
Well, I guess we're gonna graph it all and see.
Yeah.
no, it's staying on.
Okay.
So
we
we
got
needed
a
4,
bigger
so I've
pump.
done this
So
now.
that gets us
Those
to
little fancy
2.1.
tools.
We should have the extra battery on.
Yeah, 2.1.
Okay, so.
Yeah, and the
just didn't have
problem
enough
with
juice.
those people who
That was the problem.
Well, let's hook it back up.
And
Right.
save.
Right.
Well, but that's
Yeah.
what seems to be the problem. The only
Right here, maybe.
problem, of course, then is that our other
We lose
data meetings are
accuracy,
gonna be
But at least you don't have to.
not
worry
valid
about
anymore
those
because now we've had to
13
change number of
volts.
batteries, right?
Something goes wrong.
And then
Wrong way, and
We're
now it's
measuring,
on.
so we're
burning.
including the.
Oh,
I do
yes.
love the burning though. It did
Yeah.
really
Yeah, that's right,
You
and then
want
it's like, well,
just
there goes
there
that one,
and
whereas
red,
here
so
with
that
light
you're
signs,
getting
where
into
LED lights.
You see that?
Yeah.
Quantum charge.
Is this
Yeah,
the
okay,
blue
so
or
now
is
we take this out again.
So now we're
That should
that?
not be-
Something is.
Turns out.
There's nothing there, and then if we unhook the lead.
And it's on again.
Which is
Yeah,
the big,
so we're
which is
getting-
the,
So blue was a 2.4, and then the green was like 2.1,
Why, this is the blue as well.
when we had it going. Because it should be going up. And I mean, we were rounding in one decimal place, which is why these two numbers are, reading is the same for the red and the
Yes.
yellow, because we were only in one decimal place. Yeah. Definitely see.
However, you're, well, no, actually, yeah, if we're trying to across the lead, then it should be fine.
2.3.
So what's the other information
On.
that we need tonight?
So yeah, well, we can round that. So as I said, that would have been 2.1 and then 2.4. We want to add to our data. We'll see how it goes. And then I need to grab the UV.
Now, the UV, we're gonna need our, that'll pick up infrared.
Yeah, phones will pick up infrared.
So how are we gonna see the UV to see if it's?
We'll just have to look for a signal. That's about all we can do. See, with these, I don't see the vibration color on every time I take that off, plus I like my because you're right, there's no way to see it, right?
Unless we got like some UV beads and we're able to charge them up, but that takes a huge amount of energy.
So like years, not even semesters, you will like just see.
That's an interesting one, so yeah.
See if we can get a, like
So you're like,
a signal. Obviously, there's no way to see it.
But I still have to do physics, because some kids decided that they need it, so now.
Right.
Now, if it's totally pure, we shouldn't
Or
be able
I
to
don't
see
know,
anything.
their parents were.
Yeah, I know.
Let's do this.
Teach it.
Or that's very good.
Very good. No, but the extra battery. Look at that.
Okay, so we got 3 now.
Okay, so we are getting a reading.
But she'll be a reading,
On?
because that's a resistance
Ah.
circuit, right? So.
Well, no,
I do that.
Well, no, I
Or
think
you can
just because of the.
What do you think of this?
No, I don't think
Let's rethink.
Yeah,
what
that we don't-
Oh,
so. Up, sit, don't do it. Came undone.
that's not gonna help it, right?
Why is it doing that?
the best thing for everybody.
Okay, positive, positive, right?
Rearrange.
But it's still,
What's going on?
then we could look with the selfie count, it's got different filters on there, right?
Something to take home.
No, it's not. Well, it would show them the colors, which
Yeah.
again makes sense that we would see,
It's not physics, it's just.
like logistically. But we said 3.5, right? Is what we got? Did you read it?
Why? basically.
But the 3.5 is only reflective, we've got 4 batteries in there, right? Like, it's not saying anything about the LED that's lit.
True, well, we go back to the 3 batteries.
And then,
The
you know, we'll look at our
negatives would be
2.2
short
or
side or
whatever,
long
right?
side? Negative short.
Because I don't, as I say, it's all connected, so.
Negative short.
So, is
Yeah, 3.4, okay.
Okay, so we got something.
But we haven't shown it's actually, lighting up, right?
Oh, I know, that's the only one I'm worried about.
Wait a minute, hang on. Oh, I got it backwards. I have the positive on the long window, don't I?
These are transition lenses.
Oh, it is, okay, yeah.
We could put these in front of the LED and see if they darken up.
That's positive.
Right, that should be.
Okay.
I know, but I don't, I
Let's
still
pump
don't
this up
see
again
anything
here.
though.
Well,
Okay.
we won't see anything, but they'll get darker as if you're out in the sun, right? Because they react to the UV.
Maybe.
It's
Probably so little that, well, mine are transitions too,
I
but.
said it have to be pretty sensitive transition lenses. or
These ones are the extra active, they'll darken the car. Which filters out the UV, right? But,
A whole lot of nothing.
I'm not sure that the power that we're expecting is that.
3.6,
These weird readings.
is what it read for a second.
It's dropping pretty consistently quickly, but.
Are you guys getting a higher energy? You guys
We
are-
were, but we've had to like, we've been using more batteries too.
We've been having trouble getting them to even light. Because with just 2 batteries in some cases, we weren't, as soon as we tried to hook up to measure, the light would go off.
Yeah, same.
Okay, so there's 2.2.
Because that was what we were having happen.
You were getting the light go off?
Yeah, as soon as we tried to measure, once we got into the blue and the green, it was fine with the yellow.
This is
and
what
the
we
red.
were getting.
It's the purple plate that has to be.
The magic purple Play-Doh.
Purple.
You imagine, no, it can't be.
Well, obviously not, but
No, well, no, don't ever say obviously not.
Seems. There's some magic of the
But did you
purple
guys get
plate.
the
So we have,
Oh.
Yeah, like ideally you want the lowest possible potential,
Yeah,
just
like
to
we
light
really
that thing
had
up,
to
right?
yes.
Yeah.
really cool.
because otherwise anything over and above
And then
your
the
reading
couple of
extra energy
numbers
is
did
not
not.
gonna be
Oh, no, they didn't.
Yeah.
utilized
Okay.
because of the
They would
discreteness of it.
like it does show the grade like that.
But it shouldn't shut off when we measure the actual potential.
Yeah, but why does it shut off?
We
That's a
don't
good
know.
question.
We're not sure.
This one shut off too.
Yeah, we weren't sure.
But like, it was like it was shorting out, but these things
But
are
that's
all
still-
high enough internal
But
resistance.
that's wrong. We added another battery and then it didn't do it.
I know it's supposed to do that.
Yes,
Right?
So then obviously we don't have enough energy,
we don't,
if you can't see them.
these little
But-
batteries maybe don't supply enough current to push through the LED.
Well, the other way is to do it with the 9-volt and how they suggested with the,
The resistor
no,
potentiometer.
she just did it with the, I have another 9-volt here.
Sorry.
You have to be very careful with the 9-volt though. Going left.
Well, yeah, that's exactly what.
I've used this variable power supplies that I did them too, but
But you got results, right? Yours wasn't
Yeah.
bad.
How accurate would it be?
I
You
think
won't know
those will
until
be
you
pretty
graph it,
decent
but-
actually. That one, you're gonna get good results. So why is yours, why did theirs work? And it lit up when you hooked the,
Sometimes we had to like fin it to get it to.
Well, and that's
Yeah.
always the fun with any of these things with the alligator clips is they can be very finicky to make
is
sure.
it such a thing that these alligator clips are poor quality because they were just off of Amazon? And they're not giving us
you'll lose 0.1 volts for each
for each?
alligator
Well-
wire, I bet.
Well, we said we were losing what? We found about a half a volt because of Play-Doh.
Okay, so
per chunk of Play-Doh.
Does this thing work?
Yep.
We were
I
finding.
don't have a reading here.
But that doesn't explain why
This is
No.
it shorts out.
No,
We were measuring across there, but
Yes.
the LED wasn't lit, right? You would measure 2.4 or whatever.
well, yeah, I think it was measuring once the LED went out, which is kind of makes sense too in a way because you're just measuring the voltage at that point on the batteries.
It wasn't reading a weird.
Right, at that point, you're physically just measuring the batteries only.
Yeah.
Read.
It's like the
Well, no,
batteries are
like I
lifting
said,
it
because
up
I've
to a
taught
high set
circuits for
potential,
years,
right?
and so like
And the
troubleshooting
water
is a
pump.
royal pain.
Yeah.
Because I've taught circuits for more years than I care to think of, but it's more the like, and this is all, was always the issue, was the troubleshooting, like, are the connections. It was always the connections that were the problem. every single time.
Why am I only getting 1.5 volts? That's too bad.
I'm curious. Use a different system, or it'll make a difference.
Or 2.2. 2.2 is as long as 18.
That's 2.2. Oh,
Technically, originally 2.2.
maybe something silly like you gotta roll these tight.
I'll pass it on more.
Need better hours? I will get some.
We got it.
No, I don't think that's the issue at all.
It
It can't be.
And we've killed it, 2 batteries. Oh. Just like.
Well, something is doing it,
Yeah.
right? And if something's doing it there and something's doing it here. And it's something, some factor that I didn't do. You know how you do something, and you don't know you do it, so you do something?
You won't be as accurate, but
You
I'm
go to
like,
grandma's house and it's
I'm just
different.
like, let's see.
So, this one was blue, right?
Like bacon?
This
Yes.
is our UV one, so
Let's see if we go old school, makes a difference.
Okay, so that's 2,
The long.
1.9.
By just not using the digital. The readings won't be as accurate, but for the sake of getting.
But,
I
like,
think this choice.
I love digital, but.
Maybe it should be the
I
black.
love digital.
we're on the 3 volt scale.
So yeah,
I was trying to turn off on.
What does it do? 1.7, 1.76. I'm just trying to see if there's any difference.
Turn it off.
Well, why isn't it taking any power?
This is on.
Yeah, it's on.
And this one there on science, all the troubleshooting.
Which
Okay.
means there's got the only
Coaches
information
go.
is there's enough of a draw that it's killing.
I had the same thing, he's very
Why are we getting?
optional.
So this is where Johnny brings out his vape and takes those 18650, 3.4 mils
But it's still
of
turning
full
off.
batteries that have more current.
It's awesome you guys.
Yeah, this is more my realm.
Yeah, small towns, you don't get stuck with stuff like, I guess I can do that. Although you're ready.
Huh?
That is super huge.
So now we gotta get up to your orange. You can see orange.
Yeah,
Right? Like,
yeah,
we-
I mean,
we-
not
Something that's lower than, lower than the green, because even the green was turning off.
But it's,
So,
I'm
what
not
was
unintelligent.
Katrina Blue?
Yeah.
Just like nothing may change. It's more
So
by
the
streaming.
white is 2.2.
Orange. Yeah,
They're
orange.
kind of interesting.
Wow, where's my
Kids
one
that,
point?
I went
My
in,
2
even my
volts?
NP,
I don't understand why this is
mentioned,
And my 2 volts, where did that
like
go?
learning to.
See, this is the part that's like most fun and infuriating as a physics teacher.
How to figure things
I'll
out,
admit,
right?
the troubleshooting.
Not everybody knows everything.
Yes.
Because my favorite one I've done so far is I did an out of machine version with like the motion track and then down to try and measure just acceleration. But we were staying frictionless, and if you don't have the tilt just right, then the assumption that the tension is consistent and the forces are perfect, right, for using the out of machine math. And I was like, wait a second, so we were getting like answers that were like exact opposite of what they should have been. I'm like, okay, but it's our assumption that this is perfectly this, and it does make sense. You know, we make some modifications and they don't actually work because physics.
But I mean, that's a real problem.
Like through decks or
Alright, so
calculations plan. Then you have to stand back.
How does it go from 2?
That's a
Yeah,
big
there's
a
base foundation of knowledge.
Yeah, let's
I'm a
figure
retired
this
professor at
out.
the U.S. And I just
Well,
had a
this is
question.
what-
1.8.
This is the way I'm interpreting this.
Stay on.
You don't regret
That should drop.
accepting
Stay on.
it. Is it getting bigger when you?
No, we hooked this up.
So if you.
There's some hard days.
I don't know.
That's still the same,
Oh,
right?
so it's pretty close.
Okay, so
I'm
it's
not
already
reading.
right now, we've got negative
Is there
.7.
movement that's like I knew it was really before.
Yeah.
Measuring is back.
How do you mean?
Like as far as entire air.
Oh, look,
Yes.
1.7 when I had the.
That's pretty special.
Yeah.
We're not being accurate, we
Yeah,
probably
they
would be
would
out
be
of
out.
disposal places then for this moving forward, like for an actual, because that was measuring as 1.66.
They
An
weren't
opportunity to
told
share.
When we're putting in the 4 batteries.
I don't know, we'll see. I'm not.
That's a valid question.
I'm biology.
You
because
should have, like,
Way more.
They did start.
Right, like,
Yeah.
Should be more.
so 1.5 plus 1.5 plus 1.5 plus 1.5 should be
Yeah,
0.
strength.
No, it's not.
Strength that, I think all it is
You said
And then we
that.
subtract, we subtract
I think
2.
piece of it is
1,
like
2, 3, 4. Because that was
Someone
not
was really
40,
good at
full
physics,
25.
it's just C.
Christine.
And then let's subtract another.
There.
Well, this is
4.
very math based, right? So.
Yeah.
We'll see what, for
It did
this
show a
year, this is
4
what
first.
happens.
Yeah.
Physics is second semester, or do you do it?
No, physics is.
No.
And it's the entire afternoon, so it'll be able to.
So it's the standard issue of connections, I suspect.
So are you getting connection issues? Is that the
These
problem?
only
I
provide.
think that's
certain
part of
amount
it. Well, yeah, and
If you don't
that's,
provide enough current, you're not gonna get the charge or the proof.
I'm gonna interrupt your side, Cindy, for a minute. You're talking about biking, do you ever do fast biking, or do you just do mountain biking?
Yeah, I just put a new fork on my stop, I traveled Saturday, yeah.
Is there anywhere, like somewhere within this region that you can rent alternatives?
Well, Bose, even Shaw, they got,
Okay.
even Shaw kind of a long ways away from there.
we're gonna go real old school. I've never used this, but it's the same thing, just really ugly multimeter. Just really ugly multimeter, but we measure current. It's a really ugly multimeter. But we can get a feel for how much current's actually.
So how much current should they go in, we want to make sure we get a good resistor, otherwise we're gonna hit that needle wheel, yeah.
And, it's even touching it.
Cause that's the direct short, right?
Yeah. Well, I would've thought there would've been enough resistance with the wires, you should have something, but maybe not.
If we bring it down to.
I had it on the one originally and it didn't even move. What can I put in here?
Yeah, you're close. It's just
It's a
regret.
long little snake resistor.
Just trying to think, actually I have some, hold on, might have some actual like resistor.
I think actually Western Design, I was there yesterday, I think they might, Yeah.
Five of the content.
which is what, an hour and a half from here? I don't think Hometown in New York.
We lost
That's,
them.
Well, yeah, like even Regina is like.
The beauty of Regina is, like Eric and Bert, those guys will broom in Scout Park and around the legislature now. Yeah.
I certified Buddhist outdoor group that I'm part of, and their challenge for 2025 is, 25 things to do outdoors, but the idea is to challenge yourself to try 12 new things.
You go hardcore.
And I've never gone that way.
You want to clear it up, let's do it, right? You know, like-
Not to spend $3,000 on like a sport that I've never tried.
Right now,
No worries.
Especially on fast bikes.
I'm just saying, like, I'm not,
We
I'm
could
not
get
here.
some, yeah.
Science and
all.
all,
Nine.
Mega bill.
You know, the idea is you want to go to a place where you get the.
I'm racking up my paper,
So,
because all
it-
the response to the negative.
It's a good time to buy, but
So you
like
figured
there's
out.
still,
It's like I've never done it.
I Googled
Yeah.
the frequency,
Like,
so I researched the
Sometimes
frequency.
it's just like hate it, so I'm stuck with this bike. No
And
matter how
then
true.
I calculated.
if you're a hospital member, $600 to get to the North Rock one, you've got like
Then you go, shove it in, as you go this way.
It's an okay, sorry, it's like one of those ones that,
Then I
okay,
said,
that
try
way,
mine.
you're not gonna get it for an hour.
Probably on.
Yes, and then
They're
we
both
just.
12, for the cheaper ones on sale, and then you go up.
Go to the spot.
We went
Get
up
at
to
least
one
a amount there.
4 or
But I
5.
did it this way, I tried an LED,
But-
but now it's working.
Yeah, like everything's
Yeah,
like
makes it.
this.
And then you go this way, you take your readings,
Work goes.
then you can see exactly.
Right now, exactly.
So I'm ending it
Is it
here.
very bright in here?
No,
And you're there, you're there, you're there.
Anyway, that's
Okay,
cool.
if you're having trouble, I think this, come look at this, come look at this one right here. This one is actually getting us very good results. Here, see? This is the way that actually the perimeter one set it up. And when I did this at home, I actually was frying them. But this is, see, if you look forward, it gets very bright, see?
Ah.
Okay, and if you go here, it gets dimmer.
More
And it gets dimmer.
resistance.
See, then you can't see it. And if you watch the meter, yes. Yes. And maybe it was that crazy purple Play-Doh, I have no idea. I don't know.
That's weird.
Because when I did with the purple Play-Doh like this, I actually fried my LED. And I got too much powder across, but yet when I did it here, when you did it, it was the same thing. You used a whole bucket of Play-Doh, made a roll of it, and then I assume you're getting some pretty decent results. And then this way is pretty easy, because then you can just touch it wherever, and away you go, right? You get your results, okay?
Give me about 5 minutes, I'll have a stool. and then
Okay,
I'll-
well, let's do all that together with your data. Let's just take their data that you have from yours, okay? Okay, and let's do everybody do it so they have it, okay? So now, once you get it set up, now it's about data analysis, right? So I think this setup seems to provide a better Well, what it does at least is it provides a bright light and a dimmer light. And I can't tell you why yours worked and mine worked, but those two did the exact same thing. Like you guys are getting the same thing. You guys, when you hooked up your,
The light's going off, just going off.
that's what theirs was doing
As soon
too.
as we tried to measure.
Right, and your results look pretty decent actually, just from what, consistency what I got. Now, is that a Play-Doh problem? Is that a connection issue? Or is it these cheap wires? Like,
It's a lead into the next lesson, right? That's a quantum
always-
effect. As
yeah.
soon as you observe it, you change the
Right.
results, so.
well, either way, you need some data. So let's look at the data. So open up your
Quantitative
computers.
and quantitative, because when is the light on and off?
Let's do a little,
All right.
let's have some fun with some data because there's the experimenting and there's the data. And
One thing I would always encourage if we get good data at that point is keep it as a template, right? So like, for example, like, and I don't know if you guys have done this with labs and stuff, but I find if we've done something, we're like, hey, I've got this good set of data, you know, something to compare against,
yes,
right? Such that like, if kids get really bad data to the point where like their analysis is gonna be garbage, you could always feed them like sample data, which then they can do the graphing and do the, because I think, you know, from your experience, I think this would make sense, is that like, if the data collection is really bad, or if everything goes sideways as we were seeing, then they have nothing to graph. If they have nothing to graph, they can't do everything else, right? Like the data collection, this is one of those labs, I would argue that it's fairly crucial to get, right? Data, period, right? Otherwise,
open up
we get stuck.
a Google Sheet and I will show you my sheet that I created and then you're going to just go through it so that you are probably fairly familiar with Google Sheets, but just like anything, if you're not, I don't have, I gotta hook up my hotspot.
Yeah.
There's basically, it's like the other professional.
Yeah, so all the, like, the other ones are in suites, yeah, are further down.
Right. Well, good, you've gone through a session.
Well, I went to the Perimeter Institute of Physics, but I didn't all three.
Do you have to, do you have to do the application separately? If you don't do
Why
it
am I not?
separately.
I don't know, because
Why
last
don't I
time I
have- why
had
don't I have-
and they
Do you have an
don't-
Ethernet
like, I don't
cable?
have
Just plug
to
it
do
into
second
your
subject
port
for the
in your
sciences,
computer.
I just go for one day.
Yeah, that's
and
fine, but
credit.
my hotspot one, what's the?
Like, I don't mind the seminar's pretty good,
Yeah,
and it's,
and they've actually just redone it. They're piloting a new one. They'll probably they'll start with my summer sessions. It's very
There is a
similar to
one
Right.
here, but why?
okay.
Why would
But
it
yeah, if
say
that's
my
probably the easiest-
my
yeah, I think
hotspot,
you-
why would it say I don't have
Yeah, you
internet?
probably need to submit
What setting is that?
similar.
You have a VPN with kill switch?
I think so, yeah, I would think so.
So you just need.
Sometimes if you're not connected to the VPN,
I
it'll
can
shut
look it
off,
up. I
because
just-
it'll
I
like
obviously
protect your
need to
connection.
Send an email.
Like
obviously,
if
to
you've
you.
got
I was
like-
using it on the
saying
weekend though, I just
this
used
and
my
that,
hotspot with the
so
same computer.
Okay, and that's
I have
off.
5G.
Because It'll be a lot quicker this time.
Were you
since,
in the
last time I had to show
school,
my
in the
university
building?
courses,
No.
but this time I
Like
get
there could be
recertified, so-
Yeah, radio interference or something.
Yeah.
some interference with the walls and the roof and that.
But I have 5G, 2-bar 5G.
I think you still have to submit
So,
the applications
Yes,
separately, but you can just use that certificate 3 different times.
Right.
And submit them.
right, okay.
isn't there a guest network?
I don't think,
Yes,
Yeah.
there is.
well, before Christmas anyway, the last time I looked, they didn't
Yeah.
have the summer session dates
Okay.
posted yet.
Could I go to
Nobody
one
here
in
so it
spring,
should-
like say
should
May
work.
or something
Yeah.
like that?
Yeah.
April, May or whatever, and that
Yep.
would carry over for next.
Yeah, the only thing is that they
Oh,
go,
5 years.
your 5-year renewal starts from,
The day I completed
Yeah.
those, so.
but realistically, like as long as you're within that year,
Yeah.
then they all
Your
expire.
Right.
your waffles back up.
July.
Okay.
So anything that you do in 2020.
Okay, open up a
will
sheet
expire July
and
2030
Right.
If you,
Right.
have you guys ever done,
Okay.
who's
Thank you.
graphed with Google Sheets before, anybody? You have? And you've made trend lines?
Yeah.
Okay, so that's just for those people who haven't done it, just like any program, it's a little bit of a trickier to do. I do have my sample of Planck's constant, which you can get if you want it, but it's gonna be really easy to do. So if you just open up a blank Google Sheet, you get to Google Sheet, open up a blank Google Sheet, I'm just gonna click on mine, and then you can basically just copy it, and we're gonna put in your data that you have in there and see how close your data is, okay? And we can compare it to Cindy's, we can put Cindy's data in, and away it goes. Okay, so this is the one that I did at home. These are the values that I got. We're gonna put your numbers in there, and I'll show you how to actually build it if you want exactly where to go. There is instructions in there what to do. But if you just start off with color, wavelength, frequency, EMF, and energy, you can copy down these wavelengths if you want. Normally, I just get the kids to look it up, and they could actually find their own, or you could give it to them. It really doesn't matter. If you want to give them the frequency or the wavelength. You can do one or the other. I probably knew the frequency, so I wrote them down. And so this is only going to take us a couple minutes if you actually have any comfort with the spreadsheet. So this is the same as your table that you have in front of you. You have your color, you have your wavelength, you have your frequency, you have your measurements. These are the measurements that I got, and you have your energy, and that gave me a number close to Planck's constant when I did it. So just start off with an A, and later on we're just going to format our cells using scientific notation, otherwise you can't do this and it doesn't work very well.
Is that the 600 or 660?
This is in nanometers. Hang on, I'm just going to make this bigger.
There we go.
So yeah, these would be, whoops. That yellow-green one was that, what did they call it?
Chartreuse.
Yeah, that color. I didn't do the orange one, but if you did the orange one, we'll probably just have to look that one up and see what it was. I just got some average wavelengths. I actually typed in the frequency, but we're going to get the spreadsheet to calculate this for you, okay? So we're just put in the raw data. Put in either a wavelength and a EMF, and then you can calculate the other one. I'm going to clean this up while you guys are doing that.
He's gonna give us some of the.
We're going to grab the data from there. You can grab it. You can just, we're going to try her data. Okay, I'm going to put that in there so we can try yours. And it's actually going to spit us out the answer, which is maybe not going to be fair. But
Do you want the value for orange?
did you get orange?
For anybody who might have done it. I got to 1 decimal place anyways. The internet says it's 614.5. At the very least, it looks right. It falls between red and yellow.
Right.
Sorry, which one is the second column that's given to us? Rob, which one do you?
Wavelength, frequency. Which one?
Which one am I putting in and then calculating for?
You can do either one. We'll calculate either one. Alright. As long as you find either the wavelength or the frequency, we're just going to simply take that and divide it by the speed of light. I'm just going to put in the, you don't have numbers, we're going to use these ones. 1.59 yellow, 1.64 green, 1.72. Yellow, you didn't do the yellow green, did you?
I don't know. Can you just scroll down? Oh, there.
Blue. Did you do orange, anybody? You didn't do
We
orange.
tried, but we weren't trusting our results.
Did you do the yellow-green one?
The chartreuse.
Yeah, chartreuse, is that the 1.67?
Yeah. The one at the bottom, 5.7. Yeah.
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 Okay. Maybe we can ball it that way. Unfortunately, in this spreadsheet, I actually found the frequency and I calculated for the wavelength, but it's the same idea. Okay? And so we're just going to simply take, this is nanometers, which is 10 to the power of minus 9. You'll have to account for that. So when you do the calculation to get it into hertz, you'll have to do the formula. So are you guys putting in the wavelength and going to calculate the frequency? I did it the other way around. I did it this way.
That is an acceptable percentage.
What'd you get?
17.8% error.
Okay, so we have these two numbers, right? So we're just going to simply take the, to get the frequency, we're going to take the speed of light, which is 3 times 10 to the power of 8, and we're going to divide it by our wavelength. But we got to be careful because we have to put that into whatever our wavelength is. So in this cell right here, you're going to have to take the 3,000 and you're going to have to divide it by B3. Okay? And then you're going to have to multiply it by, to get it into frequency, I assume 10 to the power of 9 is what you're going to have to do, or take it by, or else divide it by 10 to the negative 9, whatever you want to do. But I mean, you're going to have, I just used a billion there when I
Probably the easiest.
yes, it's the easiest to do. Okay? And so multiply that by a billion or 10 to the power of 9. Okay? Whatever you want to do there. But just be careful because it's going to give you weird numbers if you don't format your cells. And then you can just fill it all the way down. So I had the frequency and I figured out the wavelength, just because it's nice to know the difference.
It's hard for somebody after, not in pictures or anything like that.
Now this is the part that we really get excited about, because if you're a real physics person, we always love the data analysis. We want to know how close we got. Cindy already is, was beaming with excitement.
Well, because I'm using Play-Doh from the dollar store, I feel like I'm doing pretty good.
Exactly, but that's the fun part, right? That's what makes physics fun, right? And so,
17.8%.
this column right here, the energy, that one, you have to multiply it by the fundamental charge, which is what you're trying to do. So I just took the D3, which is your data, and I multiplied it by 1.6. And if you put in on the spreadsheet, you use the E and then negative 19 to multiply it by, and make sure you multiply it by. Then you can fill them all the way down, and away you go. We'll wait till everybody gets data in there and make sure we get that right. And then this way, if it's on your sheet and you want to use it, yeah. Yeah, I just put the data on there. What's that? So take the, yeah, okay, yeah. Just go, yeah, you know. This
Carry
is 10 to the power of 5, that'd be 14. Click on this one. Multiply that by a billion. Or times. Or times 1 billion or 10. 1 E, that would take a bunch of zeros, doesn't matter. Don't accept it. 1 E, 9. There you go, Gary. There you go. Yeah, then pull it down. Just grab it and pull it down. Yeah.
Okay, so then over here.
Yeah, and then to take that, when you're doing column E, then
That's
just
a
take
five,
your,
so digits goes right to the pretty
take
much.
your data, which is in D,
Right.
and multiply it by that number right there. Okay, so this is a basic charge. This is the basic charge of an electron. A charge of an electron is 1.6 times 10 to the negative 19 coulombs. So every electron has that charge. Okay, so that's why that number. That's the smallest energy, the smallest amount you can have.
So mine didn't work with the E. and it's
Go to, if it doesn't work with the E.
So when I times
so-
10 to the power of negative 19, and it didn't work.
Okay, so use the E, but when you do the cells, go to Format, and you see how it says number, and go make sure Scientific is clicked.
Okay.
So actually what you do is, if you do the whole table, you can format the whole table so it's scientific. And that way it'll recognize the E. Because these numbers are just too, and you should, if you're using the girls' data, you should get those numbers, you should have filled in.
Yeah, I'm still getting a problem with the E. Is there a way to punch in
No,
scientific notation on there?
No, that's the only way. Oh, you got it done.
Well, you can go times 10.
Oh, you can't use a multiplication sign, or the X, you have to use the
Use a
times.
star.
You have to use a star.
Little star.
Oh, okay.
Yeah, you have to use a star.
Thank you.
Yeah, when you're using, like, okay, when you go up here, the cell right here, okay?
Should light up.
Yeah, it's all fixed, thank you.
Yeah, you need so D3 times that number, yeah. And those are just those things, that's why it's worth doing here, because
Mhm.
those are exactly the things that the students do. I mean, they're not wrong, it's just how you see it, right?
Commands in Excel or Google Sheets are very specific.
Yeah, yeah.
The-
And I,
You could use the
and I
times
purpose-
10 to the power instead of the E as well.
Times 10 to the caret.
Yeah.
yeah. I just tried to keep things simple. That's why I just, this is just how I did, no, that's right, but that's just how I did it. And now we have our data. Do you have your data in there? Okay, so you see on the corner here is my graph. I'm gonna make another graph from scratch, and I'm just gonna highlight this, but I don't wanna get ahead of the game here before we have our data. Do we have our data in?
Okay.
No? Yeah, okay, so, you don't have to highlight everything, but if you highlight just the data that you want from frequency to energy, those 3 rows right there, you can just highlight them. I just use my shift key, I find it a lot handier. I just use my arrows as opposed to, when I clicked it on here, I just clicked on here, I held down shift, and I used my arrow keys to highlight it, just because I'm a bit mouse illiterate. Okay, and my fingers sometimes do weird things, but the arrow keys tend to work for me. And so I'm just gonna go a bit smaller, but I'm gonna go insert, and I'm gonna go to chart. So insert chart, and it's gonna take a couple seconds, but you're gonna get a mess that's gonna show up in a second. And I'm just gonna go smaller so that you can see what's going on. Okay, so I don't know what kind of chart you got,
That should be the
okay?
default.
But we're gonna take this and we're gonna make that, okay? And it's not gonna be hard. The instructions are actually in there what to do. But the very first thing we have to do is a bar graph. So we have to get it to a scatter graph. So click on the right side and scroll down to where it says scatter. Okay, now, do you remember how we highlighted 3 columns? If you look at, on the right side, you should have frequency, EMF, and energy. Now what you want is you want frequency under the x-axis, and you want energy under the y-axis. So you got to get rid of this one. So just click on those 3 dots right there and remove it.
EMF.
So those are what you want. And you can see, that's kind of a straight line, right? Maybe what you got. So we have to add some stuff. So we have to go to, are you there? Too fast.
No, I'm looking for that scatter part.
Scatter part is under setup, chart type. Okay, so now everything else now is going to be under customize.
Yeah.
Okay, so we have the graph set up, so now we have to customize the chart to what we want to see. So if you customize it, you'll see two things of importance. We got to go to these two spots. This is going to help us find the slope. This one's going to help us make it look pretty. Okay, so all your titles and everything, all right? So this is where we're going to have to go to get that line in here. So we're going to have to go to series. And you have to scroll down because you need to click on a box that's called trend line. See that right there? So series, okay, trend line. And then a line should appear on your graph. Did the line appear?
So that's
Okay.
your line of best fit.
That's your line of best fit. Absolutely. Now you want to know what the slope is, right? Okay, so scroll down some more. And see how it says label right here? And it has the word none. Okay, well we have to click on that and say equation. You can show the correlation if you're into stats, but don't worry about that. Okay, so you click on this and you can say use equation. It's going to put the equation right on top into y equals mx plus b. We're under. See, 1.06 times 10 to the negative 34. Right here, this number right here, that's Planck's constant. That's your slope. So you remember how you have y equals mx plus b? That's the Planck's constant. And then you can do your percentage, and you can fancy up your graph and put your titles. I mean, if you just did, we're probably about 30–40% off. Because if you just did a quick little calculation, if you just do 1 minus 6 over 6, you're talking 5 over 6, we're at about 66% with your data. That's what we would be. Okay? And maybe if we, and I could see the numbers were a bit lower than the ones I had, but that's what it was. I mean, data's the data, right? You can set it up however you want to set it up. Now that I did it again, honestly, the very first time I did it with Play-Doh, now that I did it again, I would use the 9-volt batteries and do it that way. But honestly, I fried them. And I just, how sometimes you get something in your head that doesn't work? And then I'm glad you came, Cindy, because that's exciting. That's how I would do it. I would do it with the roll and the U, and then just stick them in, and away you go. And you get your data.
Did you guys end up getting like higher results when you started playing with that, like in terms of the values? Such that the slope would have been like
Oh, yes.
bigger, so
Yes.
slightly more accurate.
Well, okay, Cindy.
What was the data we were getting?
Okay, hang on. Let's put Cindy's data in. Hang on. Cindy, what were your...
Do you want me to share this with you?
No, just give me the numbers. Give me the red.
Just making
It could take me 2 seconds.
Frequency or?
No, just the EMF.
Oh, EMF,
Yeah,
1.624,
1.62, okay.
1.736.
7374, okay.
Oh, you want to, okay, 2.01.
Hang on, 1.74. What's the next one? What was the, did
Oh,
you do
I
the red
have-
green?
No, I have green, just green.
Okay, green, okay, good.
2.01.
Okay,
Blue,
okay,
2.21.
okay.
UV,
Hang on, I hit it.
sorry.
0.21, I keep hitting the comma, why? Okay,
UV 2.66. And I do have orange if you want it.
I
Or is that good?
didn't graph that one.
Okay.
What'd you have for the orange value? Because I started off.
1.58.
Okay. Which is probably, okay, I'm just gonna get rid of this one. Okay, and then look at her numbers. So your value now is 5.5, is that what you got?
Yes.
So 5.5, that's pretty good. So now you're talking, you're off by 0.5, right? So what's 0.5 over 6? Well, that's 1 over 12, right? That's 16%, right?
17.8 to be exact.
Yeah.
As per calculated.
Yeah, as per calculator. So I mean, like, there's good value there. And here's the whole point, the whole idea is that you're trying to quantize light. You're trying to say this is the smallest thing that we know of. Like, this is it. It's one photon. Then it opens up all those other questions. If you just looked at some of the things that are on there, and this is what I try and sneak in, and I was, where's the lab? It's all in pieces here. If you just look at the questions, like, to me, if this was what I was doing, this leads into a whole bunch of interesting stuff. Like, if you just look at the questions, it says, what does this experiment tell us about the energy? Well, what's the very obvious thing with the higher frequency of light? More energy, right? Okay, and that could lead into the photoelectric effect. You know, we're talking about the photoelectric effect. You need more energy. You need a high energy in order to get this photoelectric effect going. And it's the same idea. It's just that it's got to get some energy. Now I have in here the lead and the pink. I said, why isn't the pink any good? And I was kind of discouraging people from using the pink because pink, you don't know what really the wavelength is. So it's not part of Roy G. Biv, but it's probably a combination of colors. And the same with the white. The white, I don't know what it would give you. And then there's a question about UV and sun stuff. I like to sneak in, anytime I can, questions about careers. Because careers to me are very difficult to teach. I never liked teaching a day or 2 or 5 days about just careers. I like to sneak it in and use it throughout the whole year. So I would put questions like, well, where is this stuff coming from? Perimeter, Waterloo. What can you do in Waterloo? What's a good career at Waterloo? To me, it's good questions and good things that you can get into. I heard you guys talking about the duality part of it, right? Yeah. About like a photon, right? Is it a wave, is it a particle? Well, this lends itself. What were you seeing there? Were you seeing a particle? Was it a wave? And why does it, if you observe it, why does it do something different than when you don't observe it? Well, it lends its idea about maybe a, what do they call it? Why can't I think? The wavefront. It's not called a wavefront.
Oh, it's an eigenfunction.
Yes.
Function.
Yes. Anyways, you can do all kinds of stuff and experiments on that. And then, did you know that the connection of quantum physics and sometimes some of the stuff with the First Nations, and I'm not a First Nations expert, so I'm not speaking on part of First Nations culture at all, but if you actually Google quantum physics and First Nations, you actually get some very interesting videos about how they say some of the stuff actually falls into their beliefs. You're like, what? Well, you're thinking like, okay, wait a minute. We know what, 5% of all matter? And all energy? 4.5, whatever.
Yeah.
Between 4 and 5%. 75% is what, dark energy, 25% is dark matter. Did I get that right? Or more or less. It's 69 and something other. But the point is, they were saying though that there's a nice way that, you know how it's so difficult in math and science to try and get a First Nations perspective? This one lends itself beautiful. And you're not even making it up. You're not even just counting fake teepees. Like you're not, but that's always the thing is, you know, make a question up and put something in there, 1 TP plus 2 TPs equals 3 TPs. That's not what it's meant to be. Am I correct?
Yeah.
This is authentic. This is actually an authentic thing that you could say you covered part of that curriculum that's not technically an outcome, but it's in there. So that's how I like to blend some of those things in when I was trying to do that stuff. And I just found it allowed me more time to do stuff like what you were doing today. Inevitably, when you're doing hands-on stuff, you know, the very first time you do an activity, don't expect it to go perfect. You know, just don't. You know, expect it to go south and try and plan for that. You know, way it goes. So, that's kind of Planck's constant. Okay. I don't know if you can use it or not, but I do have the Play-Doh you can take. I do have a set for everybody. Okay. So, if you want to do it, take a set. Okay, and use them, don't use them, take some Play-Doh. I bought, you know, it was like the the Boxing Day special. I got a whole box for like pretty cheap. It was like cool, but look. So take some Play-Doh if you plan on doing it. Obviously, if you're doing it the other way, you're gonna need one container per group, right? And so if you use the 9-volt, I don't have alligator clips for you, but you can definitely take some of the Play-Doh if you don't have Play-Doh or access to it. And anything that is here, you can take, which is not Jen's. Okay? The calculators, even though she's never used them, are hers. You don't need a fancy, you just need a multimeter of some kind to take the readings. These ones work very well because of the little clips, but anything would work. Like YRHs would have lots of stuff. You'd have all the stuff that you would need.
I would assume most, especially because with grade 9 using electricity, I would assume there should be multimeters in most schools.
Yeah, multimeter.
Of some kind.
Yes, but the problem is even like the ones that are here, they're not very accurate. And so like you got to get at least to a decimal. I would say like 1.6, because if you can't tell the difference between red and yellow, well, it's going to be, what kind of a graph are you going to get, right? So any digital ones would kind of work, but yeah, hopefully you have, that would be probably your barrier. If you go into your school and you can't find that stuff, that would be a problem.
Borrow them from shop class.
Yeah, if they have some,
They
yeah,
might
you could
have
borrow
them there.
some.
I'm sure they where else in the school would have multimeters, right?
Oh, I
And
know.
shop-
Yes, I know some of the shops would have them.
shops should have them.
Some of the schools don't have shops.
Yes, right. Do you have
Also true, but I'm just like.
We're short trip, so yours is a great resource.
But if you were, and I know some of you guys have compartmentals, and I did provide the,
I was gonna say, how many of us actually have to do departmentals this year? I'm curious myself. So basically everyone,
Okay.
myself included.
okay. Now, that in itself is a challenge, and don't expect to build a course in one time you're doing it. Don't. It's unrealistic, okay? Like, it doesn't happen. It didn't happen for me for 30 years, and I would still change stuff. Like, I would change stuff all the time, build different labs, do different things. Physics is just a growing thing. But one of the things right on the outcomes is actually the experimentally determined Planck's constant. So if you did this activity, and I know the things that you have to do now is you have to check off the boxes for the outcomes, you have an accessible thing that you could say, I have done this. Now, does it get them the best mark on a departmental? No, but it gets you a peace of mind that you have one thing that you definitely covered the very first outcome. And that is, the outcome is analyze the importance of basically quantum mechanics. Quantum, small pieces. The photon is a small little piece, okay, that has a lot of relevance. And that's what you're trying to do. And then it's part of the understanding. In my mind, that just lends itself into a lot of questions. But if nothing else, it's a standalone activity. If you're not even comfortable, you could go there, you could talk about this thing called a photon, you could measure this thing called Planck's constant, and you graph and get some data and some analysis. Personally, it would take me 2 periods to do this. That's what I have 260 when I was doing it. I would do some data analysis, and then I would help them with the graphing and seeing what they got. And then they would have some time to do the questions. And then I was always big into formal labs, but you could just simply do it however structure you like. You could do the graph, you could do questions, you could not do questions, you could just do the Planck's constant, you could do a calculation, you could do some stuff with it. Okay, so I hope that wasn't too much, but
I have a question.
yeah.
How common would it be to use like Excel essentially or Google Sheets as opposed to having students do their own like figuring out calculations?
By hand?
But I'm just curious how common would it be that people are using this as opposed to asking students to do it on their own?
I personally have gotten lots of feedback from people going to university and going into engineering and stuff. And this would be a skill that they're almost expected to know what to do, is how to graph and use their spreadsheets. And really, there's not very many places in high school anymore that they get to do that kind of stuff. So I think, personally, it's a very valuable skill. I don't dismiss the paper and pencil, but I think for something like this, you can do a lot of trials and a lot of data and switch stuff up. You can go back there right now, and let's suppose you went like, you know what, I have an outlier, like this. Let's suppose this green one's way out there, and you go back, you know what, did I screw up the green one? Let's go back and remeasure the green one. Oh, you know what, I did do something wrong with green. You can go back to your spreadsheet and put it in, and you can change, manipulate things. Look how fast I was able to put anybody's data in. Put your data in. Once you built it, and away he goes. So I think there's a great value, personally, I think there's great value. Not dismissing paper and pencil, okay? But I think when you're doing something like this, to me, I want really good results, because you gotta get excited about good results.
Well, and I redid, because when I was initially doing the calculations, I did everything on paper
Yeah.
as opposed to on,
Yeah.
so then I'm of course rounding, right?
Yeah.
So we're rounding. So I went back, redid all the calculations
Yeah.
with all the significant figures,
Yes.
like nothing rounded, and I reduced it to what was it, 13.4%.
Wow. Good for you.
So then now this, if you have a group who really likes to manipulate data,
Yeah.
what I did last year, I had the data, like they wanted to pigeonhole their answers into having the lowest possible
Yeah.
errors. So that's when you go back to this, that's what this spreadsheet allows you to do, is you can play
Yeah.
with it.
Well, and I guess I agree with you, I think the way that you did that is really valuable, and being able to input the formulas and the data, like that skill unto itself, I think is really important outside of necessarily maybe what the outcome is asking you, but I also think it's an interesting question about, like, what is the outcome actually asking them? Is it about assessing data, in which case then they just need to have data to assess and ask questions about and play with, or is it about actually being able to do the math themselves,
Well,
right? So I
actually,
just think that's
the
interesting.
indicator actually is to measure
Right,
Planck's constant.
so really then all they need is a data set, right? They don't actually need to be able to do the step-by-step math themselves necessarily.
Right, but I think that's part of the skill set that you need to go with it, and you take on more physics. But I think something like this, regardless if you're going on to do any kind of physics at university, which we know isn't a lot of people, or you're just gonna go work at Canadian Tire, I think this is something that anybody could do. I really think. I think that anybody could actually do this once you get it set up with your proper equipment. And if you're anything like me, when I create a lab like this, I put it in a box. Like I have my box and it's labeled Planck's constant or whatever it is, and that's the equipment that goes there. So next year when you have to do it, you don't have to fight and look for stuff. I know where my LEDs are, I know where my 9-volt batteries are, I might have some stock stuff like clips or something, but I would put it all together so that I know that I don't have to fight every year and look for something. Like I would do that in my chem stuff. I would put my labs for my chemistry all in boxes, or I'd put them on a shelf someplace, and that way I would know exactly where my stuff was. I could come on any day and we could do Planck's constant, you know. So, I mean, like I said, I did it different. I did it with the pedometers, and we got really, really good results. I would highly recommend not using them anymore. I would adopt this method, I really would, and try and get it as accurately as you can. I mean, if you have the equipment and you have the time and you're comfortable, but like I said, you short those pedometers out.
Yeah.
Like, I went through, and then you can't even get them anymore. Like Perimeter would send me out more,
Yeah.
but now that they went kind of away from that one, they probably got tired of sending them out.
Yeah.
Because there's a whole other set of those pedometers, brand new ones sitting back
There was
there.
somebody that welded all their alligator, was it you?
No, I didn't.
Took the time and welded all their alligator clips or something.
Yes, probably soldered them and put them
Yeah,
on there and away.
I don't have that skill set, so. yeah.
No, but exactly, but I think anybody could have this skill
Yeah,
set.
oh, for sure.
And you could do it, and it would be very meaningful and stuff, because it's hard. Like when you talk about time dilation, you talk about all the other stuff that's out there, like it's pretty tough to get hands-on stuff, right? This is pretty easy to do. Okay, other questions?
So just to echo what Ron was saying, I have my kids do one paper graph, and as most of us, we kind of teach all the same kids all the way through. We're in smaller schools, but grade 10 science, they're doing the graphing. That's the first place they see slope. They don't really see it in the math anymore. And then once they can show, yes, you can do it on paper. Well, then the next lab, we're using the spreadsheet, or we're using the LabQuest devices, and you know what? Like after that, it's all computerized and it's so quick and easy. My son's been in university now a couple of years, and I don't recall seeing one pen and paper graph, but I kind of treat that with the same philosophy as I do calculus. You know what? Like you got to show me the long way of forming the derivative, and once you understand what that's about, well then we'll use the short rules. But they need that understanding before we move on.
But especially with all these people coming from teaching all science ends and all this stuff, like I think there's a place, especially when you're in small schools like we are, you have opportunity to teach all those paper and pencil stuff in grade 10 and grade 11. Like when you get to physics 30, you you want to do some cool physics. Like, to me, this is cool physics. I don't care what anybody says. This is cool.
You don't have the time, right? Like
Yeah,
two
there's-
periods, it's
that's
just take a whole
silly.
period to do the graphs, right?
Oh,
So,
especially with these exponents and
Yeah.
stuff presented.
But boy, do they ever get mad at me when I say, oh, well, you could just do it like this, we could have done this all along.
Yeah. I don't know, that just felt like, that feels so much more accessible to me than trying to figure it out. And then you get lost in the math, or kids who make a simple error,
Yeah.
and then everything's screwed up. Whereas if you make a simple error on this, you can see, like you said, oh, the green dot's off, oh, I just entered the wrong number right there, I can find it, as opposed to going all the way back through their calculations, right? Just two different skill sets, right?
Well, it's a different skill set, but it's a skill set as they're going on. I mean, like all this kind of started when they started introducing all the Chromebooks and stuff into school. And I said, I gotta use this stuff better. And when we were privileged in Melville, because we had them probably before some other schools had them. And so kids
Yeah,
had them,
one-to-one
kids,
all over.
kids had them in their hands in grade 10. So it's like, okay, so as a science teacher, math teacher, how am I gonna utilize this stuff and make sure that it's very meaningful? And so that was, so a lot of stuff was electronic, and that's just what it is. It's, yeah,
So I come from the perspective of the math,
yes,
and Lina Best Fit is in the Foundations 30,
yeah.
and they actually use these,
Good.
and you can do all the graphing and stuff.
That's for sure.
But to add to it, after a couple of hands-on, then it's using the tools, so.
Yeah.
you know,
And
that's
as a matter of
the
fact,
sort
before they got the Chromebooks, we actually did do the same lab, and we actually entered it on there, and then we actually took the graph on there, and that's how they did it. They actually took it on there as well. So yes, the TIs were able to do all that years ago. I mean, these things could do it 30 years ago.
Yeah.
I mean, that's how old that technology is. I mean, it's cool, but yeah, but they still sell them. That's the cool part about it. How much stuff they still sell 30 years later, that's the same. Okay, let's change things up totally then. We're gonna tame the particle zoo. Oh, we're gonna go for lunch.
We took longer with the blank Scots than it's a good budget, which is, oh wait. you
I'm gonna,
asked.
okay, we're gonna look at Pine Sconset, just give you an idea what's going on. And then then we're gonna run down and see if it's ready, which I'm sure she'll have ready. If not, I guess we're going out. Do you have any idea if it's ready? Do you mind if you have a minute? Just, otherwise, if we go down and it's not ready, we're just wasting. Please, yes.
Okay.
Yeah. You can walk through the lab. Yeah.
That's, you
Yeah.
want to see all of our.
Yeah. We'll clean up then while that's happening. But this one won't take us, we're not gonna spend near the time on this one. This is one of my favorite activities. Anybody ever done this one?
once
You done
or
it?
twice.
Once or twice? So you know the answer.
It's been a while.
Okay.
I won't say anything now.
Okay, so what we're gonna basically do is we're gonna play a little bit of a scientist, and we're gonna try and look for a pattern. That's what we're gonna do. And I start my modern physics unit with this activity. This is my start. When I start modern physics, this is the activity that I use because it gets the ball rolling in my mind about very small things. And basically what happened in the late 50s, when they fired up the linear accelerators, they have all these brand new particles that happened. And they went, oh, they're not just protons, electrons, and neutrons. And it didn't explain it. So like the old Rutherford model didn't explain what was happening, and they had to create a new model. And so this gets the idea going of the standard model, which is a model that's is up there. And these beautiful posters are around. They're getting a little ratty right now, and Jen says she's going to replace them. Now, I was telling her the story this morning. I said when I ordered those, I thought they were like just small posters. And they came in these great big monstrosities, and so they will probably not live there much longer, will they? Yeah.
We'll see how
No,
long it
you-
takes me to afford to replace them.
Yeah, but anyways, that's what the Particle Zoo thing starts off. It's a really cool activity. Kids enjoy it because I would say a third of them can maybe get the answer. And I'll be totally honest with you, the very first time I did the Particle Zoo activity, I was in Perimeter, is when I did it. And I just found it challenging because I was thinking different. Like I was like, you know how you sometimes when you think something, you think it's the way it is, and you keep thinking that same way. Yeah. Well, I was thinking that same way, and I couldn't get the pattern, and it drove me nuts. And so, so that's kind of what we're going to do once we have our lunch. So, which raises an interesting question. I think you're supposed to be here till about 3 o'clock. But if we have a shorter lunch, we can shut it down whenever. We can shut it down maybe earlier than 3 if we want, if we work through lunch. But we can go, I think we have to get out of here though. I think that's important. And then we'll see how far we get. I have, obviously, I hope you got some value out of this activity. But I mean, the longer you spend with an activity, the more comfortable you get. So if you take it back home and do it, then it becomes your activity, right? That's what the most important part is. Because it takes time. Like I remember my first years of teaching, I would come here at like 6:30 in the morning, and I would just do labs and activities, and I did so many labs and so many, because this place at MCS had so much stuff to offer. I would play with all kinds of stuff. And I kept changing and modifying and changing all the stuff I would do until I finally got something that I settled on. And that's probably what happened. I got old and I settled on stuff as opposed to keeping on going. You know, because it is cool, like you can change the same lab like this one and make it just cooler, more modern. Like you were excited. How many times have you done this lab?
A few.
But you were excited today, weren't you?
Well, like, because I just, that was dead bedtime, I didn't answer. Sorry. I would go back and manipulate my data to get the answer.
So I believe it's a soup and sandwich, so I hope that fits into your diet. If not, we're not going to feel offended. The washrooms are on the way. We can walk that way. I see we can probably go to the cafe. You can wait. It's okay. It's okay. You don't have to be the perfect student. Yeah, she was the perfect student. Yeah. Unlike Mick and I, we probably weren't the perfect students.
Probably not.
Yeah, that's what makes good teachers.
Yeah.
Yeah. So, and we'll go do that. But yeah, that's a fun activity. And then I'm going to show you after lunch. I'm going to introduce you to something that I showed Jen with a Moodle page that I developed. And I got some assessment stuff on there. And I want to introduce you to that may be something down the road that you might be interested in. And I was telling Jen the reason I adopted Moodle was because I was really tired of students not coming to class and not writing tests and skipping classes. And so to me it was a way to, in my mind, not beat the system, but have a better system that provided some real accountability for learning, for assessment. And I'll show you that tool that I like. I don't know, I hope they're going to continue supporting Moodle. Do you think? Is there any talk about getting rid of it?
Well, ask the coach. You probably know better.
Now that there's no DLS, is there?
We still have access to what we had access to before, but they're not expanding it, so.
Yeah,
Kind of, I guess, is the answer.
Well, yeah. It's just too bad EDSB doesn't do the stuff that Moodle can. Like EDSB's a piece of crap. Like, it really is. I mean, in terms of, recording marks, fine, who cares? It goes to the parents, great. But in terms of doing the stuff that Moodle could do with feedback to the students and getting assessments.
As far as actually like a learning platform, it doesn't work
Yeah.
quite as easily.
No.
But I know like we have, some of our grade 7 teachers are doing like a cross-school project and we use Moodle to facilitate that. So
Yes.
we do still have access to it, we can still build things in it, I'm just not sure how widespread that is.
I was having lunch with the Regina Public guy that looks after EDSB, and the question came up, how do you guys like EDSB? And we were talking, there's another guy in there too, and he said, well, you know, EDSB turned out to be the best of the worst. It was their best option at the point. There's maybe some problems with it, but it was the best of the worst was how he described it, so.
Yeah, and yeah, it was worse, that's for sure. Yeah.
I use Google Classroom.
But you're correct. Without actually having known other platforms, if we were given, as teachers, when I was a teacher, if I was given EDSB and call it, I don't know, NextB, and I said, okay, which one do you choose? Maybe I would have chose EDSB as well. Because maybe the other one was worse. I mean, we don't understand what worse is. I mean, it's hard to believe. Yeah.
Give you a good note stuff.
Yeah.
It's just what we got and what we're using, it's not going anywhere.
No, but that's what I'm saying, like, we don't know what, there's other platforms that are out there that could be a lot worse.
For sure.
Well, and really EDSB replaced Maplewood, right? Like it wasn't initially designed to replace Google
Yeah.
Classroom necessarily.
Yeah. And don't get me wrong, I got good at using EDSB. I knew what it could do, but then you just learn its capacity. And then that's what it is. I mean, it's just a way, the beauty of Edsby, this was the beauty of Edsby, I'll give you a plug, was its ability to actually communicate with parents. That was actually its flagship. That was its golden key that was better than what we had. So we had no communication with parents where parents could log on and check marks and they could do stuff.
Well, I think that's was the long-term vision.
Right, and truly, all the rest of the stuff never got developed. They promised us it was going to be developed. I remember sitting in there. I was sitting at that meeting when they had it. You know, that it's going to do this, 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 and this. Well, they never did that stuff. You know, like the app, is the app still the exact same app that we got? Like I couldn't even change a kid's mark on the app. Right?
Yeah.
What's that?
You can access it like on here.
Right, and it's just like, okay, that's fine, but that was years ago, and people, don't get me wrong, we requested this and asked for it, right, to get that changed. Yeah, but you're right, the ability for, is it right?
I think it was already.
Okay, let's leave SB alone.
Quit picking on it.
If only you knew the hundreds of things we've asked them for.
But that's what but I have done it too, though. I mean, I put in those same requests, because that's kind of who I am, right? I'm like, can we do this with it? Can we do that with it, right? And it's just,
They deal so many places all over the world that they have to be a front for so many different systems, that it's kind of not always that easy. So.
well, right, that's what I'm saying, we don't know what the other systems are, so this could be the best. Okay, let's go for lunch. Cafeteria.
Hey, Ryan, there should be one extra meal because Lisa's not here, right? 'Cause
There's lots, she's got lots, so
I got a guy doing a PAA assessment.
there's lots, I.
There's like a sandwich, like it's like a
4, 5, 6,
cheese
7,
roll.
8. Well, it might be.
There's lots,
Yeah.
there's 10. You can say.
I have to go join the event.
We'll do that after this. Blair, we'll go for lunch.
Thanks, so Ron, this was fun.
Yeah. It was fun, it's always fun.
Shouldn't have brought up the Etsy swear word here, sorry.
Yeah. No, but it's a real thing though. I mean, it's a real barrier.
Right now, I'm going to a meeting with my grade 7 teachers at 12:45, and then I'm meeting with the
Oh, yeah.
So Ontario, we still expect, so some divisions use Etsy.
I have time for lunch break, you don't.
We had
I know.
It's
one of those things that was like, well, I don't have to, like, I'm not responsible for anything, so I wasn't really like, you know,
Yeah.
oh, I've got a plan to make sure that I'm organized, but I was like, oh, I just have to be a lot of places
Right,
and answer
yeah.
a lot of
There's
questions.
always a lot of things going on. Shifting gears all day.
Yeah.
Okay.
time we have like minutes.
I don't know. I still chuckle when I walk in this room. I'm like, this classroom is huge. But like
But
my
it's a
classroom.
class and a lab, right?
Yeah, it's both.
That's huge.
But like when I was, like my Ontario classroom, which was both as well, class and lab, was way smaller than this, and I'd still cram like, but we do it, I had like 3 rows, and I'd have all the desks sandwiched together.
Yep.
So I'd have like 30 kids. And then my lab benches, it was like,
What's your biggest class here that you teach? Like how many?
I lost a bunch, but my biggest at one point was 34.
Okay. Fairly large.
It's all relative though, right? Like, so my physics, 30 for this coming semester is scheduled to be about 15, 16.
Yeah, yeah.
My physical science started at 30 first semester. And I've also got like a foundations 20 this coming semester at 30 kids.
Right, right.
My smallest class is 22, 24, and that includes a couple of like 11s, 18s type,
Yeah,
In the mix.
modified alts kids, yeah.
which wasn't a thing in Ontario, so that was new too.
Right.
I mean, there was no modified at all. It's like I taught, we also didn't have EAs in the room. Like that's not a thing for high school.
Yeah, no, well, I don't.
I don't know, maybe I'm just lucky because I've got,
I don't get
because
a
I've
lot
got,
of EAs.
yeah. But it's something that I'm not even used to the option.
Right.
Like we just didn't
Right.
have them in our high schools,
Yeah.
period.
I do have support for my science 18 student. He, yeah. But the 11s are on their own, the 21s are on their own. And
I don't know,
that's-
the one thing I noticed was interesting is like the science 11 is literally the exact same thing as the science 10 shy of one outcome in the motion unit.
Yeah, and they use the old science 10 curriculum, including the weather unit.
I don't know, I've been using the new stuff and just teaching my 11s the same as everybody else.
Yeah, I had to take out the lots of the physics, because the 11s I have cannot, like the math is not happening. So that looked a little bit different.
Yeah, that's what I'm doing right now. I was gonna say, because you were just starting the motion just before Christmas, weren't you, Blair? I think, from when I was in with you at the beginning of December, you were finishing up your weather.
Yeah.
Yeah.
Yeah,
Like,
and that's the
seriously?
first piece that they see on graph. You know, they used to do it in.
I have a new student starting tomorrow. Oh, look at you.
I forget which math class it was, but now, yeah, workplace 30.
Mhm.
So they do that.
So for 3 weeks.
Yeah, grade 11. Starting this morning with an unknown start date. Okay, well, I guess we don't know if he's starting tomorrow. And then I have one coming
But,
back semester 2, but at least starting at the new semester. So
Yeah,
it's-
that's
I don't know, tomorrow I'm doing like drawing
The
back. from,
question
like,
is
tip to
where do
tail
we
tomorrow.
begin sourcing
Yeah.
out lockers for these kids? 'Cause
Yeah.
All kinds of things. I don't know what we are.
Because then I'm doing I'm using my motion carts and my new ramps and my sensors to do an acceleration lab. I think Thursday, Friday.
They really like to get their hands dirty with all those sensors and whatnot, right? So.
You know what, like I said, I got lucky, I got a grant from the casino
should
and I
say
bought all
no.
sorts of fancy new
Right, you
equipment.
can start second
Yeah.
semester, right?
That obviously, if you're feeling ambitious and you wanna try something out, you are welcome to borrow, because I can easily get to you.
Then this somebody.
Yeah,
That's one of them, like,
gonna do, let's.
Because I got magnetic field
Write the
sensors
final
too.
and they're
Yeah,
not gonna
I
take
do
credit
have-
instead of just.
So I know you had some of the cards.
A couple or maybe 3 of those. I don't have as many.
Well, I know this
But
child,
my
he
sleep
has
keep on
been
getting-
on and off in this.
Okay, but
Just
that
like
he's
He's
fine,
fine,
just
he's
just
not
dying
wrong.
so bad.
Yeah.
But
yeah.
he's going, like, this
I always
grade
did.
11 group of boys are, they're all
yeah, but-
like athletes, like hockey players. See, they're-
Those lab quests, like it's the same
they're,
idea as the
you know,
TI-84s,
Yeah, yeah.
right?
And I have a
You
son in
your
that
interface,
class.
that's what it is, and then you've got your sensors. But,
Our Western
220
Ontario starting to get to the point where the
pound
batteries were getting ready to
Yes.
blow up because they were swelling.
yeah.
Because we had the lab question too, like what model we had.
Yeah,
No, I-
And then we had
You
the
won't
money,
take
we were
physics
able to
science.
switch over to Bluetooth.
yeah.
So we got rid of our lab quests, but I liked them.
Our batteries, I've replaced a
I wanna say
couple.
there's only
Ours
They
were
weren't
just-
actually that
maybe-
bad, they were like,
maybe
I don't know, for the 50 bucks a battery.
Oh, that's a small group for you guys,
Um,
And they're
or?
not
But there comes a
very
point, as you say, where
academic,
lab
so I'm
quests are
not
reaching
sure
all
what's
those
gonna happen to my
Mhm.
physical
things are maybe
science
12 years
20
old, right?
Oh,
So,
yeah. Okay.
It's
Like,
like
there
throwing
could be
good money at bad money at that
So
point,
it's
right?
the opposite of
Right.
Norfolk,
Yeah,
that's
but I
our
bought,
biggest group,
just
there's
buy with the money I
48
had, I bought the tracks, I
And I
bought
will, I have 28,
a bunch of
29
carts. I
registered
bought
for
one
physics,
set that
science,
has the
20.
sensors
Now,
in
there's
them.
3 of them that I'm gonna lose
like
within
for
a
the,
week.
like the force.
Yeah,
because
that
they're
just
being
means
built
we need to
like
cut them
in
off,
the
yeah.
Carts.
No
Oh,
problem.
yeah, yep.
And then
So
the rest
I can do
are
momentum, like
like
collision
your
flap.
hardcore.
So is that the Pasco set
Like-
or?
Wow.
Yeah.
Well, at least then.
It's all the Vernier
It's
stuff.
easy, I'm gonna
Okay.
love teaching it, yeah, it'll be so easy.
Even
And
the
then
ones that I
Vernier
have,
doesn't seem
I
to
think
be
that,
as-
kids
Yeah.
that I do have.
I don't see
think
them as
that
much
they're
anymore in
gonna be-
Saskatchewan as what I used to.
And that's his.
They're just not real
The
motivated like
Sparks
that.
that's the
conference, they had
intense.
some, but I
Like,
think it
it'll
wasn't
be
Vernier,
sad.
I think that
Even
was
the
the Pasco set
ones
up
with all
there.
the talent and
Okay.
potential in the world.
Yeah,
I'm
so I
just
bought
not
a
interested
bunch of
in
magnetic
their
field sensors
passion.
with the intent of,
Right.
trying
Nothing like getting
Yeah.
the attention
Yeah.
of
Collaborative
collaborative.
person.
Oh, I was probably the worst. I was a terrible student.
You told me I can't purchase scripts.
We can give hints maybe.
Sure.
In these envelopes, there is a deck of 25 playing cards. Oh, they're just little cards. Okay? And you can read the preamble. I'll spare you that. But basically what happened was all these little particles came out of when they fired up the linear accelerator, and I'm gonna pass these around, you can look at them. You're gonna get in a little group of 2 or 3 or whatever you feel comfortable. And if you just want, you might wanna work with somebody different, but honestly, this is your thing, so you can work with whoever you want to. You can do it by yourself. So, I'm gonna just throw one of these up here and just show you what one looks like so that we can all see it. And I'll try and pick, there's some interesting things that happen here. Like I said, this was my starting activity. As you probably guessed it, I'm a lot about activities and doing things, and I feel comfortable over the 30-some years that I taught that some of the methodology I did, I had a good reputation of producing engineers out of here. So probably because of maybe the hands-on or whatever it was, they were somewhat successful at university, including my own son. Okay, and my kids are just data heads, so they're just numbers people because they had no choice. Their mother was a lab tech and their father was a physics teacher, so they just got a good dose when they were kids. But anyways, this activity is a great way to start things off, okay, I think. Okay, it lends itself to a lot of things. If you want to go into the standard model, if you want to go into more particle physics and different things, in these playing cards, there are some things on them. Is that going to focus?
Yeah, it did.
It did? Oh.
It's trying to.
So, this is delta double minus. Now on it, every one of these playing cards has a particle. It tells you what year they were discovered. Most of them are in the 50s. Okay? When they were discovered, they found these particles. With all these, I'm not sure how familiar you are with atomic theory, but basically after about 1940s, things kind of stalled after the atomic, nuclear kind of thing happened. And then they fired these things up and they got all these brand new particles. And all these brand new particles, basically the old Rutherford model of protons and neutrons and electrons had to be rediscovered. So they talk about an energy. This is mega electron volts, which really is, when you guys are calculating joules, you can actually calculate this in joules by simply dividing by the value of E, okay? And so you can get this in joules if you wanted to, but they're going to use mega electron volts. There's a spin, okay? And so this spin has 3 halves. I'll show you another one. It has a Q, which is a charge. So the charge is in coulombs, and it has this strangeness, which has a value of 0, 1, 2, or 3, and it has these values. So you have a spin, you have a charge, and you have this value called strangeness. Now strangeness is really a strange value. Jennifer and I were talking about it just this morning. I said, Jen, what do you think strangeness is? And I went, we both agreed that we didn't really know the right answer to give you. To me it has something to do with decaying, and you said it has...
Well, yeah, it's, in terms of that seemed to be the one thing that made sense.
Right, how fast the particle will exist, and there's other parameters to go around. It's not a linear kind of a thing, but it has these properties. So there's 4 properties on this card. Now, just like Mendeleev, when he set up the periodic table, he looked for patterns. And the patterns, they put it into different groups. And then it lent itself, and there was missing spaces in the periodic table. So here's what's going to happen. you are going to be given the task of these 25 playing cards. There is one card missing, so a 26th card. Now, in order to win the Nobel Prize, you have to figure out what that card is. That's how you get your Nobel Prize. So you're going to win a Nobel Prize in physics right here, one of you guys, today. Maybe everybody is going to win, I don't know. But what you have to do is you have to try and get what is its mass equivalent, what is its spin, what is its charge, and what is its strangeness value. This one's going to be more of a bit of a guess, but you might be able to get close, okay? So you have to kind of basically more or less look at some of the other values around there. I'll give you some more instructions in a second, it's on there, but you're going to have a set of these cards, okay? Your first task, okay, I'm just going to go through the instructions a little bit with you because this is totally different than what you were doing. Like I said, the very first time I did this, I wasn't very good. Okay, so here's what you need. Okay, in your group, what you have to do is inspect these for mass, spin, charge, and straightness. It says, no, straightness like spin, mass, and charge is a property of particles. You can read about that a little bit later on. That you can get into. You don't need to know much about that other than it's another property of these particles. Sort the particles into 3 distinct groups based on the information on the cards. The number of the cards in each group should roughly be equal. So you're pretty good at math. There's 25 cards. You can probably figure out how much in each group. Okay. Which property works best for this one? Okay, so that's what your first task is going to be. And then once you get them into their 3 groups, then you can continue with a bit of the instructions. Now, just like anything, if it's your very first time doing it, it's always nice when somebody comes around and helps you just a little bit if you're kind of stuck. And I would do the exact same thing. I'm not going to let students sit there and spin their wheels for 45 minutes on trying to get the right groups. So you got to kind of get the groups figured out based on those things. So separate the cards, put them all out, get some space. We'll get rid of the stuff. You can go to a new table someplace. We'll leave the calculators out just in case we want to get into some alpha and beta decay later on. And then we're going to go there. And of course, did you win the Nobel Prize? We'll figure that out in a bit here, okay? So, you can do it by yourself if you want to be that keener, okay? But there is all these sets of cards, and when you leave, I did print off everybody sets of cards. You have to cut them up, okay? Okay, that's the only thing. I know, yeah. But you get your students to cut them. But you can't cut them because the answer's on one of the sheets. This stuff also is Perimeter Institute. And all that stuff will show you after we do this what it's going to take. And then I'll tell you what I would do with it. We won't do it because it's going to take about a 30-minute video I'd watch afterwards. I'll show you where it is and you can go. So here's your set of 25 playing cards, okay, that you can play with. We'll probably won't drag this on a crazy amount of time, but we'll probably take about 20 minutes, 25 minutes. What do you think? How long is it going to take us? Yeah. And I say we're relatively intelligent because that's all I ever think of me. I don't think myself as really intelligent. I think I am relatively intelligent. Okay, but it doesn't mean you can do this, okay? So, here's your cards. Find a partner. Find 3 people if you want to do it, or else do it by yourself. You try by yourself. Yeah, and I got more sets. These ones right here I know are 25. The other ones I need to count.
Spin together.
I just read this piece for you're out of here, there's a version of it.
Yeah, that's it.
There's a variation of this for your
Yeah.
table.
Oh, there's way more in this set than I think.
I don't know. I don't know what's, they're all different.
Just make sure you have 25 and I count it.
It's all Greek.
Well, that's what it is. It's all isn't it though? Isn't that cool though? You remember all those symbols that we want to know.
Sorry. So do we want to start by sorting them by your group?
Where's alpha?
Alpha is a particle itself.
Yeah, I mean, I reckon Lisa was saying.
So does that
Video.
fit?
She can
Okay,
hear by
so
television, but there was no
that
video.
needs
She
to
said.
be,
Oh, I don't know.
they have plus or minus.
Okay.
First thing in the morning.
She said she said. But it's like over Zoom.
So what about arcade?
Maybe she doesn't, actually just tell her to refresh maybe.
Okay.
It's like €0 spin. Different. Just a bit, but we have a pause.
Hang on.
Charges,
I'll see it.
Over pulse though.
Yeah.
But it's close.
There's also probably.
It's actually not terrible. Maybe I'll just try.
That's way too weird.
Let's move it so you can see what they're doing here.
So you put particles into 3 distinct groups based on the information we get. The number of cards in each group.
Oh, it's working now, she says.
Stay by yourself.
It's working now.
Okay, well, what can we divide up equally?
Use one of the properties, one of the 4 properties.
Okay.
Divide. Use one of the 4 properties on the names.
Yeah, I got one more stuff. So we look at all these are all 1380,
Oh.
except for this guy.
What you're all
Yeah.
See if I can do this.
You can join with the groups, of course.
Let's just see if we can
Sorry,
understand.
seven, four of them now.
Oh, right.
Probably not.
Like I said, I wasn't the,
Right, sure. So then,
And then we also have in particularly the sigma that causes. So, they go weird.
You're wrong.
Charge.
Charge of 0, this is a positive one, this is a negative one, and then this is another charge of 0.
Which changes the strangeness.
The minus, the plus, and the 0 again. Minus is 0, and then the star minus the star
But these,
0.
Okay, wait.
but these don't have any charge. But these do. Oh, proton would be positive.
okay, fair enough, yeah.
But neutron is no charge. Oh.
All right.
So, we need.
Need 3 groups. 3 groups, 3 groups.
ETA, estimated time.
Okay,
Yeah,
and
then
then
this
the
one
other
is
is
no
the
charge. Well, then this is
There's a.
Yeah, charge of plus
But then
1,
what would
0,
you do
and
for
minus
masses
1, right?
anyways?
Yeah.
So we want to redistribute our
I think
groups?
that's what we should do.
Okay.
Yeah.
All right, positive, so we're going over here then. Okay.
Like, how would you even divide it up by masses?
We'll put the neutrals in the middle and the negatives.
Yeah, like where's your cut off?
So they're equal
groups. What about?
Wait a second. This one says minus 1.
But that's the street and not the math.
Oh, I was looking, I thought it said.
7, 7,
Then you have the strange.
and 11 then.
I'm only seeing
Zeros.
So I would
Yeah.
say we need
I don't
to
see
have
any positives.
1 off the center into each one of the sides.
Oh, okay.
Balance out the numbers. But is that actually a thing?
Spin.
No, let's either that or.
You can have a spin of 0.
You need, just give you, you need 2 groups of 8 and 1 group of 9.
We'll make 2 groups of 7 and 1 group of 11.
No?
Okay, what is our strangeness then?
Like, well, 'cause we
0, minus 1, 0, plus 1.
No.
So that could
I
be
don't
our
remember it.
cross,
I used to
right?
do this activity with them when, like, in Chem 1, and we used to do.
Oh, and it's the strangest of minus 2.
I used to have these little piggies.
Get your groups?
I don't know. No, we're still, because this is not like equal. We went by like charge. So now we're looking what else we could divide them into instead.
There's no positive strangeness. So this is a positive strangeness, and that's a positive strangeness.
So how
None
many?
of those are positive
Half,
strangeness.
0, 1,000. There's 2 here.
Okay, so then the only other way
We could do that and just see how the needs of each.
Okay.
Okay, so let's do, what do you want, James?
Let's do
0, half,
Yeah.
okay.
What do you got so far?
We were doing the charts that we said.
Okay.
And then,
Okay.
and then after that, we do
Did you do strangeness? Did you do spin?
spin.
So
started as within
So this guy
Okay, so what, you need a group, you need three
and
groups?
that one
Okay.
are very small
Group of
maps.
eight.
That's like the smallest of all.
Okay, so.
We're still not equal, but close to equal, okay?
But then Kylan's are kind of the next level.
3, 4, 5, 6, 7, 8, 9. Two groups should have.
Yeah, they're always gonna start.
Four of those.
So these two should look similar.
That's okay, well, all of those sounds like there's related with at the same time.
So that's close.
They are.
So we haven't looked at or discovered.
Actually, you have to
Well, I
doesn't matter.
was just, I know, because that's the first aspect. We have so that's.
Yeah, I haven't done starting part, so I
Yeah.
take one of the
But our
three.
spins are all 0, -1/2, or -3/2.
Take one of
That's
the
sort of
3
three
groups,
groups.
organize
I
the
don't think that makes
particles
sense.
into rows and columns based on 2 other characteristics. Should we just
Did you
try
guys
this one?
use groups?
Yeah, we use.
Okay, okay, so now,
No, okay.
now you got your groups.
All right, I'm gonna pick one group.
We all put, okay, so now you're trying to make a pattern for this group, a pattern for this group, and a pattern for this group. All the same kind of pattern.
Yeah.
Okay.
And there'll be one missing from this one, or well, it could be more than one, but, you know, sorry. On the periodic table, you know how there's gonna be, oh, that one fits right there.
Okay, so there can be gaps.
Yes, there can be gaps, but, so now you have to go, okay, so now you have to use your
Now
other
ones
ones.
we got are in the groups.
Rows and columns now, okay? Spreadsheet, make a spreadsheet.
8, and there's our.
Yeah, and then you can try organizing it.
Count right on one.
Pick groups now? Right on, okay, so now make a spreadsheet. Make rows and columns. Take these and make a spreadsheet. Make like rows and columns, organize them in rows and columns.
Okay. Okay.
So I think our biggest match should go at the bottom.
All right, I can go, it within
Yeah.
within each group is what you're saying?
We'll go plus
Get your
1,
groups.
0, and -1 for the columns, and our rows
But
will sort out
it
by
goes
mass.
slowly.
Okay.
The heaviest mass.
So what about the zeros? Are the zeros the least?
Got
So you
it.
got
That works.
Now
I'm
organize
good
these
with that.
They are.
into rows and columns.
Yes.
Whatever you do for this rows and columns,
Yeah.
same for this rows and
So
columns.
let's start.
Same for that rows.
Oh, and then I'm gonna plus 1 charge.
See, now you gotta organize into rows and columns, with the other characteristics, right? You've got spin out.
These two are the same as.
I wonder if we could like make
When
a
was one discovered? I think both are same
So-
way too.
Works really nicely for the numbers.
In each set, choose
And
the
then
same
we wanna
pattern.
check out.
Try and create the pattern, and whatever pattern you use for this one,
Oh, so it's
this
all
one
the way around with
has
the.
one missing. This
Um,
one's a complete set, this is a complete set.
negative 0.
So how did you organize this?
I feel like you kind of do this, don't you? Like this is a little organized. And then this one is
Positive on that, okay. Let's keep
Zero
it
again.
consistent, and then
Yeah,
we'll
and zero.
mix up negatives on the right.
And
Negatives on the
then
right,
you
yeah.
want your masses and this is a minus.
Heaviest on the bottom.
And it's plus one.
Switch these two.
I think that's okay because this one went from 0.
And that one's
plus
probably
2.
here,
So
so
it's like
put that
going
one
from.
down.
This one has a plus two.
Now, this one's a little awkward because we got 4 neutrals in.
But you're also.
And then you
Yeah.
But why are these in the same row?
Yeah.
So maybe
Can we put? What about your Q's? Being
I
zeros?
would say this
How many zeros do we have?
Yeah, this one looks, they are relatively the same
Yeah.
mass, but they don't have to the right if they're not the same, right? As you go down, same spin, same charge, straight spins increases.
That just doesn't play for the rest.
This one's have keys, this one's straight spins increases. These two, they don't.
Which one we're missing?
Increase straight spins.
But it could be a 2.
No, you have to get,
Increase for the first
Get
two,
the
and
pattern
this
for
just
those
drops
ones.
by,
apply the pattern for this one, and see which one's missing.
this one drops.
Figure out
But
the
maybe
pattern,
the strangeness isn't.
and then find out what's missing.
It
You
kind of
gotta
looks
organize
like
those
this
ones
one.
as well. That way you can get, because these ones are gonna confirm how your patterns.
Right.
and then apply that same patterning. I'm not saying you're wrong.
No.
So apply your same logic, apply your same logic with those ones, and see if your patterning still works. Right?
I like my brains.
I don't want to say we want that.
Okay, so right now,
That's
what do we
where
have?
the delta
We have
plus delta zero minus, and then the sigma star plus nine. I think we got a
But our
star
charges are all
or
over
a
the place.
plus that we're missing. Is that a star plus?
Oh,
Okay, this group again? Or church?
So you,
Because
you
wasn't the
are
nine
making a
that
grade
we were
between
supposed
the
to
yeah.
have?
One of those. I have more ideas parties back in the day. So I feel like.
So we did that with this one. Which two characteristics did
we did it by spin.
So then we.
Because these all have the same spin. So no spin. Look at the charge.
Two other groups that had needs and answers.
I think the masses are, I think we feel real nice, because you know, like, the masses will fall into place, try to call it, okay, by based on either charge or strangeness. Okay, so let's say, what we did, from zero charge.
Yeah.
Wait, this is strangeness started at zero, that doesn't go negative.
Because here you have
Oh, okay, do you know what I mean? Or you start at like -2.
You can't have it for zeros, right? You can't have it.
Okay.
Makes sense, yeah.
Minus 2 is that one kind of over there. I see that being more likely. So I think it would be like.
So
Because if
we
we,
should jot
let's just, I
down.
think you have to like physically move them over and over again. Okay, what if we go by, do you want to try strangeness or charge?
Okay, so right now I have strangeness, these are all zeros. Good lens with zeros plus.
Okay, then let's try this row.
Kind of like this, right?
This zero, so we have either strangeness of -1 or strangeness of -2.
For this particular.
Do their masses increase or anything?
Okay, so here we go, yeah,
Oh, no. it's
Yeah.
maybe not.
And then the strangeness is
I think it goes down.
because it's all your.
Keep this massive.
Yeah.
And it works across the schools.
Okay, so we don't have that.
Four. These are within four. This is higher than the middle by 4. This is lower by 1.
Yeah.
This is higher.
This one.
3 on this side, higher by 3.
Because
Higher by 1.
Well, the whole point is undiscovered, right?
hang on, no.
-3, the mass is greater than.
What's negative?
This one, I think it's been 3.5.
This one's missing one. That's why.
Just write it down.
Hey, going on all right.
Okay, let's just do this. Okay,
So, yeah.
so now, they all have the same spin. Okay, so what do we want to do? It's gonna be either charge or.
3 quarters, or 3 counts. 150, about 1,700.
What do we start at?
Of course, my vendor thing.
That's at 31 then. Instead of 54. Okay, I agree.
Got it?
And they're.
Well-
Okay.
It makes sense with what we were thinking.
Oh, mostly plus one.
Oh, I like the one more, the one that I've done, has one
It's helpful to have all 3 groups, eh? Like,
Oh, yes, yes. But I was saying, like, the very first time you do it, but it's not intuitive. That's why it's a very good exercise. Like, it's a very good.
it makes us think, right?
Absolutely.
What?
I'm like, oh, I'm good at this. I'm pattern and the physics person is like, I'm not that good at this. And you realize how much you think, oh, well, people like it before you see like an easy connection. It's only an easy connection because you know the answers. And then if we don't know the answers, like, dude, that was way harder than I thought it was.
I was at the Canadian Association of Physicists annual conference. I think it was like Saskatoon. And they came up with a question, you know,
So what do you got so
who
far?
really understands
Well, we're
quantum
not sure if
mechanics?
we need to go by
There's
charge or
doctors, you know, there's
strangeness.
the physics professors,
Because we have to
everybody in
base
there.
off the
Not
3
one
groups of
person
the
raised their
spin.
Well, I'm
hand.
trying to.
And then finally someone says, well, I'm a little uncertain about quantum
Okay.
mechanics, charges and
Stuff
stuff
like
like
minus
that,
one.
right? But
Then
So
zero
zero
is
to
zero positive.
Yeah, okay.
And then you can then organize your strain is a different call, right? So maybe do charges this way and strangeness is the other way, right? So you got all minus, which way you going?
Okay,
So you're gonna minus one,
Yeah,
minus
you
one,
almost need
0, 1.
fermions and bosons, right?
All minus
Yeah,
one,
you talk about
right?
it.
All minus
I always
ones.
feel that.
Where's another minus one? Any more minus one?
No.
Okay, so then go zeros.
You know, like this
Okay,
is.
so your zero,
I've done
what are the
this
strains
one.
you're doing? Plus one, so that's gonna go in this row, right? Okay, so then now you can
They
organize,
actually.
now do the strangeness in the order, right? 0, 1, 2, 3.
But they have to be able to, okay,
There you
we
go.
do 6, right?
Yeah, exactly.
Otherwise, oh, it's just a big pie in the sky, no, let's move on.
Yeah.
Hey, where are we going tonight,
And I
right?
wrote, and maybe it's more, I will workshop
Yeah.
activities, connect to
Oh.
something else, like I can't.
Okay,
do these
so
isolated.
now you, okay, so now you got it, okay? So now try to do it now the same way, okay? Try doing it, where's the 9 marks? Where's the 9? Okay, so where's the 9 that way?
Well,
We were
they
like-
send you all those resources for free, right?
Yeah, no,
Okay, so you want your charges, first of all?
Well, you have to,
Minus
see what we're doing right now.
Or minus,
Yeah,
is
what
there
we're doing.
minus? Yeah.
Okay, now what do I do with this, right?
Now where do I take this
Because-
and go next, right? 'Cause-
Otherwise, you're gonna feel like a substitute walking into a room with a plan, like, okay, what am I doing here?
Oh, exactly.
Even though it's very good.
Awesome.
I still,
Screwy.
Yeah.
Oh,
60 or
oh, I'm looking at the wrong, I hope it's a S. Okay, Q, sorry.
There's another 0 there.
Yeah.
Yeah,
Okay,
But I like some
change.
alright, there you go. Now you got to straighten this.
Yeah.
Oh, yeah. There you go. Yeah,
Well, they're huge. Like right now, my eighth grade softball, like my daughter's in it, but they're very, they have good academic.
Oh, yeah.
But they're also cooperative.
Oh,
So it's like, you throw whatever you want at them and they'll persevere and work on it, right?
okay, you got your, hypothesis?
I have. Last year.
So you actually said work to do.
Charger.
So they're the ones that are 0.
Then one of them is zero. I mean, like, there's two of them, like, the pi 0 and the 8 are identical.
I know.
But if you look at the rest of the patterning, the 8 is should be there.
But so is that why though? Is there
Yeah.
the ADA, is someone over discussion or something else?
Potentially.
So.
Okay, once you get your answer.
Some strategy.
Otherwise, the rest of the
A
patterning.
few that I see, but like all these 54, all those in 60, 62, right?
You got a Nobel Prize?
Wait,
See?
charger.
This fella, for doing exactly what you did, I mean, not exactly what you did, but
I just seen
probably took some data from one of your accelerator. Yeah.
I'm totally out.
No, that's not the answer.
Oh.
Oh,
The answer's covered right here.
Oh,
This is,
like, wait a minute, how did-
sorry, this is the other one he discovered. The ETA prime, but that's not the one you're missing. The one you're missing is my undiscovered.
Okay,
Okay.
I felt really inadequate there for a
No,
second.
no, just relax. Okay? Mega minds.
I still feel really bad.
No, hang on.
It's not zooming very well. There we go. Yes.
Okay, that's the same
Lower
number.
than 10.
Well, where did you get omega from?
That's
And
opposite.
don't worry about the name.
That's different, and that's different.
I don't know the
It
answer.
was a minus.
Yeah.
Fair, I don't remember my.
It's,
but
your
they're all
spin is
the
obviously
same
the 3 halves.
Yeah.
The charge is -1. The strangeness, which of course you never had strangeness at -3. And that one wasn't discovered until 1964, but then he discovered another one. This one right here. But yes, those were the discovery he made for the Nobel Prize. Okay, so, I don't know. So, who's close? You close?
I would say close.
Close? Close is good.
Depends on your standard deviation.
It was in 3 sigma.
Oh, you mean your energy? Is that what you're-
No, I'm just talking about what defines.
Oh, what defines close? Particle
I
physics.
see on the bell curve.
Yeah, you got the bell curve, you're fine.
But the way we get that sorted, that would be your eta minus, right, from the out there. The omega, those don't have any omegas.
Yeah, he just makes their own bit.
Who's gonna disprove it?
Yeah, disprove it. Okay, so we put the cards back in there. And throw them back in just in case Jen wants to do this. She has them all cut out for her. So,
Later, when I get to this in June.
oh, whatever.
Yeah.
You use it. Like I said,
It's a good activity, like I said, I've
It's,
done very.
I personally think it's a great activity. I mean, I guess put it this way. If you enjoyed it and you thought it was challenging, think about if the kids would think it was challenging and enjoyable. If you thought it was annoying and frustrating, well, then that's could be how they think of it, right? And you're gonna have all kinds in there, right? That are gonna feel the same pressures.
It's good.
Okay, fire up your laptop. And let's see if we can get ourselves into a digital world. See, there's your budgets for your mileage.
Oh.
Look at that. While you're just sitting there firing it up, I'll give you the link here when you're going in a minute. But this is the video. It's called Beyond the Atom: Remodeling Particle Physics. That would be the video that you would watch after this, which would get you on the road to trying to explain the Standard Model. And her very first comments when you started off on here, she talks about the particle zoo. And they call it the particle zoo because it's what created all these brand new particles, and they had to try and explain how they existed. And basically the whole idea of quarks and the whole idea of all these smaller quantum pieces of model. And then there was a piece missing until about 2000, I can't remember the exact year, maybe 16, 18, when they discovered the Higgs, they confirmed it for sure, the Higgs particle. Right around there was a particle missing for many, many years in this 1960s, and Higgs proposed that it was supposed to be there, and they couldn't find it until they got the energy high enough, is what it was. And then they finally found what it was. And then you could go into, basically, into the Standard Model of what an atom would be, someplace in there.
And you're gonna share the link for that?
I'm going to share everything for you in a couple seconds, okay? We're going to see if we can get into something called Moodle. Okay, so if you go to, and I'll make it bigger for you. If you go to elearning.gssd.ca, you should get that page that comes up. I don't know if you can read that. Just elearning.gssd.ca. It should be a link right on here. And I assume everybody's logged in through their account, right? Like their GSSD accounts on their computer. Okay, so this will be easy. elearning.gssd.ca. Don't go log in, don't press anything. We're going to log in through the staff.
That's
Okay.
on the page that I got like a
I'm on the Zoom one.
student email.
Might have already logged us in too.
Oh, yeah.
You got which page?
Yeah, it's
That one.
Perfect.
Oh.
Okay, you put staff probably, right?
Yeah.
Okay, so-
Oh, no, it just
This
opens
is just
it.
automatically popped up.
Huh.
Although it doesn't say, it says log in on the top.
Ah,
corner.
yes, in the top right-hand corner,
Yeah.
the login.
So log in, the top right-hand corner.
Oh, okay.
Okay, click log in then.
There we
I'm
go.
not even allowed on the computer.
But you have to log in through the staff.
Oh, I think I've got the old Moodle link on here. I had two, so
No, you need
Yeah,
e-learning.
just go up top.
Yeah, I
You
think,
need elearning.gssd.ca.
You just have to hit the
I
login.
think this was the.
Okay, and then now we'll scroll down, we'll log in through staff.
There we are.
I am
Perfect.
learning.
No,
stuff.
you let me in. Scroll down.
Well, you already put us in.
Oh, there we
Okay,
go.
staff.
Hey,
Staff.
we better get rid of the kid that's in Bio 30 that's graduated 4 years ago that I keep on getting emails about.
No. Log in through staff.
Participants, we'll get rid of them, now they're in here. 2 participants found. Okay,
They need to scroll staff.
it's gone.
Okay, now you should have MCS
All right.
Physics 30, right? Is everybody
That's
in?
gonna save you a bunch of
Okay.
time.
Now, okay, now you're only a student right now, but don't worry, you can always change your access. If, on my page here, I have all the courses that I used to teach on there, but I'm gonna go to Physics 30, which is the same as your page, okay? I'm gonna take you to, you should, if you click on Physics 30, you should have a tab or a little box that says Modern Physics. You should have everything else as well. But just click on Modern Physics. You know, feel free to get sidetracked and ignore whatever you have to do. Okay? But the very first thing, I actually added some stuff and I called it modern physics. And under modern physics, there's the Planck's constant lab. There is the sample spreadsheet, which we did. There's the perimeter, the whole resource package from perimeter. So you don't even have to, you just click on it and it'll give you the whole file. There's the video, there's the particle zoo activity, and then there's all the outcomes for physics 30 that are there. Do you see all those? You can click on any one of those and they should work for you.
Just go.
Are you not in?
Yeah, it's just being really difficult to
There
start
is no
seeing.
scroll like on in there,
Oh, what a pain in the butt.
so I don't know how.
Go control minus. Too many minus.
Okay, did you go to the corner? That's all?
There we go. Now, we still not scroll down? What's it doing?
So the trick I did
What do you do?
was, had it, so it was
Yeah.
at the top,
Yeah.
Oh,
and then I clicked, and it got me enough that then I could use my
Oh, your
arrows.
cursor.
Oh, use your cursor here.
Yeah.
You try it. Click on it again, try it. Click on modern physics, see what it does.
see, that's where you would go next.
Yeah, okay.
Yeah, the up and down arrows.
Up and down arrow.
Knocking down that, well, I hope you didn't plan on doing anything else in modern physics.
Over the whole year, like, you have to pick and choose.
Now, this isn't why I brought you here, okay? I brought you here for a different reason. I want to give you a test, okay?
I don't watch Usain Bolt run. No, you can't, it's not.
Is it?
Oh,
It's
that's the
just a
assessment
YouTube
part.
video.
Assessment after lunch.
Yes,
Okay.
I have assessment, so you're getting a test. Okay, so, these resources I'll share with you in a bit, but I want to show you what I think is some of the value. There's links on there, there's all kinds of stuff that you can look at, and feel free to use whatever you heart desires, because technically, I made this when I was an employee of GSSD, so I own nothing. Okay, so it's actually their property, technically, right? That's what it is, so my property, your property, our property, okay? It's really what it amounts to. If you close this up, and if you go to the place that calls exams, and this is the units that I taught, those are some of the labs where we handed them in, and you can look at all that kind of stuff, and we can play with that if we have time. But just go to exams, just for fun. And you'll see that there's a whole bunch of exams there. Simple motion, vectors, force, conservation, electricity, a summative assessment. Do you know why it's called a summative assessment? We weren't allowed to give final exams. COVID, remember COVID? Couldn't give a, so this was
Exam
developed.
by any other name.
I didn't have a final exam. Okay, but anyways, so
We called ours final.
after COVID, I use these only as basically review. I didn't actually use them as exams. I did paper and pencil, but my students found them very, very useful as review because it was already created, the wheel was already made, they were there. Some of these questions, you can make them and they can generate random numbers. So if you have your favorite slope question or your skier going down the hill and you want you to do it at 20 degrees and you to do it at 15 degrees and you to do it at 13 degrees, they can generate random questions, okay? You could also generate more random things. You could have your 20 degrees with a coefficient of friction of 0.1, you could have coefficient of friction of 0.2, and away you go. That is a whole different workshop, okay? That's something that you don't want to fill your brain with right now, okay? We can do it very simply. We're going to do a bunch of multiple choice. Click on modern physics. Okay, now, you should probably have enter quiz, right? You click on it? Attempt, okay, attempt quiz. Okay, mine says preview because I'm not a student. So, if you attempt it, there's 20 questions in modern physics. My phone's ringing. The password is modern. Wrong answer. Yes? Yes. Okay. Sure. I'll probably just bring it at 8. I'll probably bring it at 8 anyway, so, okay. Okay, thanks, Emma. Goodbye. Okay, so, the first couple questions, you got it?
We're all for, thank
Go ahead.
goodness for Oppenheimer. Boring movie.
Well,
Are we supposed to do
what?
this question?
Yeah, start it.
Oh. No. Oh.
Do I remember this? Is it Professor Slaughter? Yeah. No capital? I don't think so. It's okay. When I first got my laptop, I hit the cap key, and it was like a teaching thing. I had to keep it this whole time. I was like, oh my god, I remember that.
Don't worry, you don't even have to pass.
Did you sign my passwords incorrect? Is it capital? No.
Don't use capital.
I typed in modern, right?
Yeah, MODERN.
Yeah.
I could take the password protection off. And the only reason I would use passwords is so students just wouldn't go ahead and use it.
Yeah,
Like, because otherwise they might do it without having the knowledge in it. You're assuming that you have taken some minor physics.
I don't know.
See it? MODERN.
Oh no, what just happened?
Okay, don't worry, you can't screw this up. That's the beauty. If you get kicked out, you go back in and it'll take you exactly where you left off at.
And sorry, you said that this changes it all for you?
Uh,
Little bit
then-
or no?
Depending which ones you're doing. So like that one,
Yeah.
the only thing this would do is actually change the order of the answers.
Okay.
So this, you could randomly put numbers in here, but it wouldn't make any sense.
But all your like other ones would.
Yes, but the ones with numbers, well, you're gonna have the same question with a different number for an answer.
Right.
The questions that are very regurgitative, like the Oppenheimer question,
Yeah, yeah.
it's gonna be the same one.
Yeah.
But, in my mind, if I was doing those kind of things, I'm okay with that, because if I want you to learn that Oppenheimer, I just threw Oppenheimer on it,
Yeah,
it's
yeah.
fine, because it's a movie, it's actually the reason it's there, otherwise it's a bad question, right? But the other ones, you wanna learn, maybe that's what the tidbits you want to learn. So now how you were saying about the scientists that you
Yeah.
want, so if you just had a bunch of these questions, and if I was doing departmental, I would actually put them on there, and here's all the tidbits you have to learn. And did you get some wrong when it took you to the hint?
No, I haven't gotten that far.
Okay,
Or I wasn't.
you must have gotten right then.
Well, I don't think I was checking them. I think it was just saying next page.
Tough one. That's
I haven't
the,
learned any of this stuff.
no, I know, yeah.
So for the particle question you got here is the assumption of the workshop authority.
What is the direction of the force?
I'm just, in terms of the intent.
We have a positive charge.
Just in terms of what was the intent of the question.
Yeah, it's a positive charge moving through the field. What is the direction of the force of a particle as shown in the diagram? Exactly.
It's meant to be QED, right?
Yep, you have to use your.
The random rule, exactly, but that's why I'm just finding out what charged particle is.
Oh.
Because you reverse it if anyone electrons,
I forgot
right?
about that, it's megahertz.
It would be a positive.
That would be the assumption.
That'd be the assumption, that's.
But you
Yeah,
see why I'm
and
like.
then-
Oh, yeah, absolutely.
100%
You
different.
gotta use the left hand.
I gave
Hey.
up on that one. Well, the other, have you ever heard of the other where you just literally just say, you just flip?
There, Oh,
direction, like when you're doing
I
it?
I did my conversion and I had to do 2 more.
I liked it with the same way as the right-hand rule going around.
Yeah, no, and
So I did it that
I
way.
yeah,
was
same thing, with the same premise, and I did the same
thinking
idea,
megahertz
but it was just
canceled
basically
out
like,
with my 10 to the
you
8.
just had them
Right.
put their
But that was a
thumb,
factor
so
of
like, if
100
because if your thumb was the
Yeah.
direction
And then I
of the
dropped
flips,
my
it was
Yeah, we
going,
did
decimals
bubble
and I
chambers.
rounded
you
it
just
100
flip
different.
them, right?
Yeah,
Uh,
that's, yeah.
So if we're assuming that it's, okay.
So this is the force, this is the current.
Yeah. Current or speed, yeah,
Yeah, your current, yeah, the current, yeah, your speed, yeah.
magnetic
This is your
field,
force,
and then
magnetic
force.
field.
Yeah,
Yeah, your magnetic field,
and
yeah.
then force is
Force is
your
it.
middle finger or the palm, depending on which
I
one you
always
teach
said
it.
it was, I always said it was FU, so it's the force.
Yeah, that's fair.
Yeah, that's how I knew it was the force.
Yeah, see-
And in both rules, if you use just this one, this is the current.
Yeah.
So I liked it because then it kept the thumb as current.
Yeah.
And then it was,
Yeah.
So then that way, to me, you had two things that kind of were the same, so if you forgot that, you only had one other one to do.
Yeah, but then,
But
then,
you know-
but then the second rule, don't forget, then they swap, right, magnetic field and your fingers switch for coil. Right, because then your thumb's in the direction of the magnetic field for the coil in terms of which direction north is, right?
But you
With
can
the
still,
three
you can
rules.
still do it this way though.
Yeah, true,
You
because
can
then you
s-
cross your fingers and.
You can still do a
Yeah.
coil.
Yes.
You can still do it.
Did you know the question they put on the environmental
No.
deals with left-handed?
Of course it does.
Oh, for the electronegative. See, that's just a bunch of bullshit. Like, because current is defined as a positive charge, which I think is garbage in the beginning.
Current versus traditional electron flow.
Electron flow, current. Which one do you want? Pick one. Right? Right, that, I mean, that's,
By definite, sadly, right?
but sadly, but right, but, you know, when you're teaching at a junior level, I mean,
I know, you know, try to demonstrate it and get
Yeah.
them to understand it
yeah,
and the funniest thing was, when that first came into the curriculum, I'm looking all over for
The
resources.
next one.
And I pulled off stuff from like university sites.
The head of the
And I have
arrow.
found exactly the same worksheet from two totally different universities. Answers were different.
What the heck is this? Is this a matching question?
And
Yeah,
I
look at
went,
the answers.
yeah, I think it's random.
See, my favorite part about teaching physics, I don't know about you guys, is watching exactly what we're doing right now, which is all the right hand rules,
Yeah.
and like watching the kids do it.
Yeah.
I always tell them to grab a pencil. Like that's always the one that I found I've had them do is I'll tell them to grab a
Force.
pencil if they're
Yes.
having trouble
Current.
figuring out
Yes.
the whole thing.
magnetic field.
As like a way of holding like their wire or whatever. Like some
Chucky's going,
seems to
"What
have
the
to
hell?
like
I've never
just
seen
curl
this crap."
around the wire
Right.
at some points.
that's okay. That's why I wanted, that's,
Oh my god, okay, you know what, on this one, I can already tell, even as a student, I'd be looking at the answers going, yeah.
Meh, eeny meeny.
Yeah,
you know
that
what?
looks like a good answer.
do you know what though? Because it's all relative to what you teach, of course. My students would have probably done better on that question than some of the, because I would have spent time teaching that. Like I had a bunch of examples, and we would sit there in class and do exactly what you're doing.
Right.
We'd be sitting there in class and went this way and that way,
Yeah.
and how does things turn in a bubble chamber? Does it turn this way? Does it turn that way? Where's the
Yeah.
force going on, right? But I mean, it's all relative to what you feel is important, right?
Mhm.
That's part of the electromagnetic fields.
Yeah. Whereas the radioactive ones, that's, I spent a fair amount of time.
Oh, and doing Great.
Beta and alpha decay.
beta and alpha decay, yeah. Yeah.
Gamma decay. Standard model, okay.
But I'm gonna show you something cool though, in a second here, once you get there. Oh yeah, mine does that too, it can't go down. What do they do to this format?
Interesting.
Blair, look at him go. Blair's on question 13 right here. False too, right?
There's no revision though, so try again.
Not the true and false.
You don't get anything repeated.
And actually, you know what, Bill Blair,
Yeah.
you can actually set that up so you could actually.
Yeah.
You can actually set it up so you could weight them any way you want, any number of retries.
Yeah.
Like there's no limit on the number of hints you can give. You can hint it to death. You could take off 1% for a second try. You could take off 99%.
Yeah.
You can set whatever you want. Yeah. But I mean, that's if you were using it as an assessment tool. If you were using it as kind of review and just to learn, then it doesn't matter, right? Oh, you did?
Well, formula wise, right?
Yeah, just to get the,
The
what it would be,
proportionalities.
right, yes, as opposed to, yeah, right, you're just saying more mass, less mass, more charge, yeah, what's gonna make it spin tighter? Well, that one, you know, we just did this.
Yeah, I know, right?
Yeah. Yay, finally an easy one.
Has anyone tried on Etsy putting in a quiz or anything?
I don't know if there's no way.
What's up?
I don't know, there's always like way things hand in when you make like assignment. There's always a quiz one or something.
Can
like that.
hand stuff on Etsy?
Well, like I get my kids to do that all the time. I'm a big pusher of Etsy just because I need them to know how to do things and to try.
Yeah.
But I'm just wondering, because I feel like there was some talk about it, but maybe I'm misplacing them.
If you're tired of doing it, feel free to submit at the end.
Oh, down the decimals.
Blair's getting excited.
All the same things that we always did.
I failed.
Spectacular.
Yeah, but in all fairness, you're a phys ed person.
How did I get a 0.5 though?
On this question right here, you probably had a second try at it.
Oh.
And the way I set it up is if you had a second try, I gave you 50%. So you could actually set up how many tries you get.
Okay.
You could set up how many, you could have 5 tries, and each try could take off 20%.
Right.
You could set up 2 tries, and the first try could take off 50%, and maybe the third try takes off only 10%.
Yeah.
You could actually set it up any way you want. You could have no tries,
Right.
and it's all or nothing.
Yeah.
You know, so you can actually, and then you can set it up with hints, like on your tries, you could say, did you try this, you know, some, you know, whatever, famous
Right,
movie
yeah.
or something, right? Or you could just say, well, that's it, you didn't know how to do it, so sad, so bad, right? You can set them up so they're very, like the math ones that you guys did were probably randomly generated numbers, whereas like the ones that had very specific answers would have just had randomly generated orders. So
Okay.
even if you were doing a question and somebody else is doing a question, even if you got the exact same question, your answer might not be C. Your answer might be C, my answer might be D. It will be the same answer,
Yeah.
but it won't, because you couldn't go to somebody and say, what did you get for number 3?
Yeah.
Well, I got D. Well,
Okay, well,
you know you can't get D. The answer might be, the answer is Oppenheimer,
Right.
right? And that's why you'll notice that a lot of those ones that had multiple choice had more than 4 choices, like 5,
Yes,
6,
yeah.
7, 8 choices. Because the more choices you have, then it scrambles them better.
Mhm.
Now, it's hard to think of a lot of choices, trust me. But that's why those ones, because there is only one answer for those.
Right.
Yeah.
And then the 50% makes sense. It's
Yeah,
just
so
for
then-
true and false. Like if I knew that, I probably would have clicked on the hints for the true and false and then changed them, and then still got 0.5.
Possibly. But I mean, like, the cool part with all of this is it's tracking you in real time, so you're doing it. I extensively did it for Science 10. That's all I did. My Science 10, even when I quit, I only did Moodle tests. And because I had, well, as some of you guys probably experienced the same thing, I have kids that just don't come to class. They're there all the time. And I'm like, I don't care. You want to write it tomorrow, today? And that one I spent a lot more time making better questions and more generated questions. And I would give them the test. I would even give them the test days ahead of time. And I would say, here's the test. They'd be like, okay. And the first time they would do it, they maybe got 2 out of 10. And then the second time they do it, they got 3 out of 10. And the next time they did it, they got 5 out of 10. And I say, okay, well, the test is on Friday. I would clear off all of this, and then now here's your opportunity.
Right.
And somebody'd say to me, well, I wasn't ready for the test. I'd be like, okay, want to write it again? Yeah, can I? Sure. It was no work for me. Now, this is a bit different, because this is Physics 30, so it's a little bit harder. But for Science 10, I was just tired of kids playing the, I'm not here. I'm skipping the test. I'm doing this. And Jen's experiencing that too. She's telling me, she goes, oh my God. She goes, I was telling her this when she came, I said, one of my frustrating things was, especially Science 10 to me, because it's a gateway, because you can't pass grade 10 without Science 10. And it just was all the questions on there that I needed. I put chemistry questions on there, or whatever questions you want. And the beauty part about all these questions is, you can export them, you can manipulate them. Like if I click on export, make a file, you could import them into your own page, and you could manipulate them, you could change them, you could do whatever you want with them once they're created. So if you wanted these questions and you said, you know what, I hate that question with whatever, you just go ahead and you change the question, or you create a new one, or you do it. Now, is it time? Yes, it's time. It's time to create it. But once it's created, it's fabulous. Because these questions that you did would have reflected my modern physics unit. Not yours, but mine. So when they did bubble chambers, or they did the filling in of the equation, that's what I did, right? So if you don't do that, that's fine too, because you picked the different indicators. And that's fair. I mean, only if you're not running a department like that. then I don't know. Then it's a bit of a I wish I could help you out there. I don't know how you get more, because I saw those things online, I'm sure you guys did too. You picked the samples.
Yeah.
And it's like, whoa.
Well, but they all follow a pattern, right? Like there's 4 available and they all follow a pattern. So I can surmise from that the pattern will continue.
Oh yes, how many of each question there? Is that what you mean?
Yeah. Well, and what type, like the type of question.
But it even says, so like when you read the workbook, it'll say like how many questions in this style. Like it actually, like in terms of the prepping,
Yeah.
it even told you that. I think my biggest beef with it from what little looking at it is just how like, some of those like nitpicky questions,
Yeah.
right? Like the one, like the Oppenheimer question, or
Yeah.
like, the equivalent would be like if we ever put it on like a chem test for the younger classes, is like, who developed the plum
Yes.
pudding model of the atom?
It's on there.
Who gives a shit?
That's- that's-
Is the
yeah.
answer.
Oh, see?
Nobody cares.
No, I have that
Right?
on my thing, I think.
No,
Like the
they're-
chem, from the
one
chem,
of the
no, I know.
practice
Yeah, I get
questions
that.
actually
I put
is-
that on tests when I did Science 9, but the reality check is that way I could tick a box. But reality check, who cares?
So,
And what are they actually gonna remember fundamentally? Right? Like, I would argue them not knowing that is irrelevant,
this is
which is annoying.
my modern physics unit, and it's actually on that same one as well, you can actually click on it. And this is,
It's a question. Nobody cares, that's why the kids won't remember.
but that's how those questions are. But you can see the very first activity I did is the particle zoo. And then I watched the video. Here's that video that I was telling you about from the perimeter. And then we actually went into Dalton's, Thomas, and Rutherford's theory. But there's some activities there from Perimeter Institute, some very good activities you can do that are actually relatively simple with those ones. And so a bit about the Higgs particle and about just what it looks like. This was the activity that went with it. It's kind of cool if you ever have a chance to do this. That's why there's a bunch of wine glasses back here.
We were talking about that.
Yes, you can do some scattering with Rutherford and some forces with some balloons, just hang them up. Kids have fun with this one. That just gets you into the whole idea of that propulsion. Here's your forces. If you've ever, I don't know if you guys have ever done this, the weak, strong force, electromagnetic force, gravitational force. There's some good, simple ones. The 4 fundamental forces, they're basically SciShow ones. I think they're wonderful.
Actually, videos are good.
The old SciShow ones. The new ones aren't quite as good as the old ones were, but the old ones were very good about what the different forces are that hold the nucleus together, the strong force and the weak force, and how some of those bosons and stuff interact. But they're very simple, which is good. And then that's where this whole electromagnetic field stuff came into, when you guys were doing the question with the right-hand rule, stuff. And so I spent some time doing that on there. But so that's why when some people say you skipped over it, I spent time doing that. So that's what would reflect my assessment, which of course I hope yours would reflect your teaching. The bubble chambers and spinning, and then here's your whole idea with your spectrum that you guys are doing with Planck's constant on there, just in terms of your energy and frequency. And then of course, there's a little bit of why the light bulb glows a little bit, different spectrums of colors and different heats, which is kind of cool. And then of course your Planck's constant. And this is what I did with Planck's constant with that pedometer.
Yeah.
That's what's the difference. And then what people want to get into, of course, at the end, if you did some wave-particle duality, that's actually one of the outcomes. Here's a good little video on the wave-particle dualities, which is kind of cool and kind of explains to you the observed and not observed one. Alpha, beta, gamma radiation, there's good videos on that. Then the radiation lab, which depending on what we want to do next, we could actually pull out the things and do some radiation stuff. That's what I would do. And then, of course, one of the questions on there was about, the equations, the alpha, beta, gamma decay, which to me, that's one of the easier things to understand. Like it truly is. I mean, there's a lot of stuff that's hard to understand. It gets pretty deep pretty fast. This, once you do it, it's probably one of the easier things to do. And it's probably a question on the departmental. They usually have one of these questions on there. So I would make sure I would do alpha and beta decay for sure. Because normally this question's on there. It's one of the easier things to do that doesn't take a ton of time to teach on there. And then there's lots of questions you can find. You can rob these if you want. And then of course, this sheet right here. Do you think I could find a new one of this? I wish I could find you. This is back from the 95, 96 kind of stuff. I can't find an updated one. But this one right here is very good. It talks about medicine, and it gets into alpha and beta decay. It looks at penetrating power, alpha, beta, gamma, and then it gets into the exposure, gets into where and how things are exposed, ionization, radiation, like radon gas. I found this excerpt about how many millirems different things take when you get like a chest x-ray versus going on an airplane or a pilot or something. And then the rest of the stuff that goes with it. And it's actually pretty good. It's old, super old, but it's actually very simple. That gets into the different medicine stuff that you're getting into about some of the stuff that's on there. So that actually is on there as well. That actually is one of the things where it says the Modern Physics booklet at the bottom there. It's all in PDF because it was actually done on the smartboard. And then I actually changed it to a PDF is what it was, just so students could download it. So that's kind of the Moodle a bit. If you had a chance to play with it, which I'm sure some of you might have a bit, where did it go here? Did I lose it? Oh, here. If you have a chance to play with this, and you're more than welcome, if you want access to more stuff, more or less, I set up stuff with a bunch of these short little videos, and they were just me basically trying to explain something. And the kids, anytime the kids wanted something done, I'd actually add another one. Like they would say, and I would just archive them. It was a place to archive them. And so if you had a velocity versus time graph or any kind of thing, you could put them on here. And most of these are done just with my smart camera. That's all they are. And some of the booklets I have on here you could look at. I don't know what's a good one. Like maybe hitting a deer, I don't know. But there, I don't know, this is going to show up. All they are is just me writing something down. And it's just explaining how to do it.
This lesson is just going to do a question on a truck accelerating from rest from 2.3 meters per second and how far will travel between the third and the fourth second. Now there's a couple ways you can answer this question, so maybe we'll take you through both, but let's just do an inventory.
So that's where I found the blended learning or the value of Moodle was very good, because I could send kids there that missed and they had an instant resource that was easy to find. I didn't have to sit there every day and write something on a Google Classroom what we did. Because to me, I personally found that very annoying and time consuming. This, once it was there, if I did this question a year later, it's still there, right? I'll say, you know what, you missed question 4 when we did it. Well, just go to Moodle, click on it, watch the video. If you have a question, let me know. And then kids told me that sometimes their most valuable part about my Moodle was actually when they were trying to study. They'd actually go and watch the videos again. That's what that was their study. They'd go through the examples in class, and they could pause them, and they could go through them and do it. And to me, that's more, in my mind, what blended learning should be, is something like that, not always posting stuff every day, because kids can't pay attention. You know?
I agree. I had students who said they always went through it again at night when they were doing their homework.
Yes.
And you could tell the difference between that student versus the other student. And on the flip side, when they were absent for an extended amount of time and they'd say, well, tell me what I missed, and it's like, didn't you watch the videos online?
Yes. You know,
That's your first defense. Once you watched it, then come with questions.
Yes. Yeah, the building of it takes time, but it truly, the benefits on the back end are so good. I had a gal, she sat right there, and right where you're sitting. I have to go anyways.
That's gonna get replaced now.
Yeah, you know, and she hardly came to class. I thought, there's no way she's passing this test. And she get right to her test, she got like a 70. I said, wow, I said, I'm pretty impressed. I said, how do you do that? She goes, I just watched your videos. I went, ooh. Oh yeah, I guess the videos were worth something, right? And so, anyways, that's all I'm really gonna say about that. If you're ever interested and you truly put the push on and you wanna learn how to build that or do that, that would be a whole day in itself, and we could work on it together and do it. And by no means anything here should be like an expectation. It should be, is this good for your operation? Can I use this to make my practice better? You know, and it doesn't happen overnight, trust me, because you have so many pressures and stuff on you. that's on that. So, kind of, that was my deal till about 2 o'clock. That's what I was gonna take. And then we have sharing, and I asked if anybody wanted to bring activities. And I noticed you guys were talking and doing stuff. We could do other things, I could grip into Jen's lab here and pull out some stuff, because she says she hasn't moved hardly anything. So, so I said,
right?
it's
That's
time.
time.
Yeah, but see, it doesn't matter. It's not going in, there's some stuff that's been there from the 60s, so.
I threw out one thing that, like, when I open up, like, newsprint that's from the 60s, I'm like, and if you still hadn't opened it, I'm like,
Time to go.
probably doesn't need either.
Yeah. So, will the people, what would you like to do? Do you want to play with radioactive rocks? Do you want to do some beta and gamma testing? Who's ever done that? Is that something useful? Are you going to be able to get the equipment to do it? So,
Well, there's always the hard part, right? Because how hard was it for you to get all the rocks that we've got? They're not gonna use.
those rocks I got well before.
Mhm.
Well, there's a lot of other things that are radioactive, but those rocks are awesome. I got 6 radioactive rocks that have alpha and beta decay that are pretty good on them. We can stop them, and I got other radioactive things that we can test, that we can go and do. Like if you, where was this? If you went, you can't see it. It doesn't really matter.
I mean, I guess my question is, for those of you who are
Yeah.
taught this stuff at some point, right? Because obviously there's some people who haven't, it sounds like, from our newer physics people. Like, what types of labs have you guys typically done for this unit? Right, would be a good general.
Sure, yeah, whatever,
broad,
those activities, yeah.
Would be my first thought, right? Like, I mean, I know for me instinctively, like, something like this would be good. I haven't done the Planck's constant one myself. In the past from Ontario, I did like a virtual version of the milk and oil drop experiment. As one of the things, but it's not exclusively, right? I also did stuff with half-life activities, because that's an easy one to access.
Well, speaking of those, who's familiar with FET? Like the simulation?
Those are my favorite.
If you
They're
need
so
stuff
good.
and you don't want to set up equipment, the FET stuff is incredible. If you don't know what I'm talking about, I mean, FET, if you want to do anything, basically FET's
Another one I
great.
mentioned, if you want to pull up, if you Google physics aviary, that's one that I just told you about today.
Yeah, I've never used that one.
Yeah, that's one I found during COVID that I've used a lot. Sometimes it'll come with pre-made like stuff to go with it, but if nothing else, the simulators are there.
This one?
Yep. And it's for like all areas, right? So if you just go at the top where it says labs, very top. And then like you can look at them by topic, you can look at them, like they're listed alphabetically by default.
Oh, you know what, I've used some of these. I've used.
But like, there's ones for modern in there, there's one for the, for photoelectric effect in there.
Oh, where's that one?
Scroll down under P. They're all alphabetically done. There's
Oh my
magnetic
God.
field ones, there's like, it's ridiculous how much is in there.
What did you, sorry, you said physics.
Physics aviary.
Hang on, let's go to the top.
And sometimes there's actually like resources where there's like booklets to go with it. Not always. The other thing that's really handy about this site too, because this will cover like pretty much every possible, like there's something for basically every unit for the Physics 30 course in here, 100%. I've done a friction lab from here that I used for, and you can graph it and you can get like coefficients of friction. Like I've done a bunch of
used some
these.
I recognize them.
Yeah, I've
I
done a
just,
bunch of these.
I must, when you Google a certain kind, it must just come up.
Yeah, I've done a bunch of these ones.
Treadmill lab. Huh.
Like there's a ball toss one I've done for like energy of a ball drop. I've done.
No, that's awesome. I find online ones are just so nice because it's nothing to set up,
Yeah.
right? So, yeah.
You got specific heat.
I've done the friction one that's in there. I've done that one for kinetic friction, coefficients of friction. I've done that one. Some of these like they'll have, it says like there's like those blue links where it says see resources. So sometimes there might be actually like somebody's made like an actual lab document.
Oh, nice. So kind of like that, but not a little bit.
Well, more like, I mean, again, out here we don't use gizmos, but it's another where like there's something already like a pre-written piece as opposed to you have to recreate it, like some of the fat ones we can get. They've got like pulleys, ramps, photo gates, acceleration, like there's so much stuff in there. What was the one I was just looking at? Yeah, there's one for photoelectric effect in there. Yeah.
So when you guys are saying FET, what's that?
PHET.
Literally just type into a search bar. It should be the first hit.
I think I've actually.
Yeah, Colorado, yep. Okay.
So can you change the
I thought
material?
maybe you can change the wavelength.
Oh, you can change the material, look.
Yeah, and you can change the material, yeah. There's various clickable things in there.
Then you can
Oh, yeah.
change the wavelength.
Change the wavelength, up, down. Yep, change the brightness, the intensity of the light. Obviously, there's a typo there, but
Yeah, whatever.
whatever,
A bunch of
exactly.
physics people.
Yeah, can change the voltage. So you can design a lab out of it.
Wow.
I haven't personally used that one yet, but that's one that, like, I like their stuff.
This one's cool.
There's a lot of, like, there's a lot in there. Like, I've used the friction one
Obviously, we
before.
gotta get a high energy here.
Because I've used a bunch of their labs during COVID. That's how I came across them in the first place.
Yeah, we need to-
What are you trying to get to? Maybe?
Doesn't it come out, back off? What's it doing there? Isn't it just shooting the,
Detected. Yeah, but you might not have the power supply. But it's also with sodium, because don't forget it's with respect to the material too.
sodium worked? I thought the alkaline metals were better at the photoelectric effect.
I believe so, yes.
Shouldn't they be coming back off?
Let me check it, because there's another.
Electron detected, 0. Okay, well, maybe I gotta get my voltage up or what?
Yeah, it's a matter of just trying to tweak the settings, right? So, but like that would allow you to play with and do. Like, that's kind of the point of why I said something. But like there's other ones. There's what else is in here? There's a half-life one apparently they've got as well in there. Radiation detected emission spectra. I've done the Millikan oil drop from here as well.
Oh, I'm an idiot, I went the wrong way. No.
There you go.
But that was an
I saw
idiot.
something bounce.
Yeah, but that was an idiot, I went the wrong way.
Yeah,
I was, in my brain, I was thinking frequency.
not wavelength. Yeah, yeah.
And I was going higher with the
Yeah, you're
wavelength.
going the wrong way. Yeah.
Yeah, and I'm going like, I don't get it, I gotta crank up.
Oh, wait. Wrong way.
Yeah, so there you go, there's your photoelectric, yeah.
Yep.
There you go, there's your electron.
But like this does there's a bunch of good little ones, like depending on what people want to do for friction, like I know, wrong unit, but there's a really good one in here for doing coefficients of friction for different surfaces. I've done that one as a digital.
Yeah, that's cool.
There's one in here for Coulomb's law too, with hanging particles. It's literally alphabetically just like a Coulomb's law lab by alphabet. Here's one for impulse, so there's all kinds of
There's
stuff.
actually lots of them.
Yeah, like I said, I've used some of them.
Well, the problem is it takes time though too. I mean, it's no different than a hands-on lab.
Yep.
You still have to design it and go through it. It's just that your results are more consistent.
Yeah.
Right. And you don't have to have the lab full of.
You don't need a bunch of stuff. All you, and with budgets are, it's terrible. Yeah, I don't know how your budgets are, but Jen was saying her budget has been to crap.
Mine was very tiny. Teeny tiny.
She's got a host volleyball provincials and there's a bunch of money thrown at you.
Yeah.
Keep everything working. But yeah, to replace sensors for LabQuest and stuff, it's like, oh no, I guess we gotta repair those and get out the super glue and fix
Well, and
them,
that's
right?
scary, and like I
So,
mean, it is what it is, but.
If you have sensors from Vernier, anybody sensors from Vernier?
Yeah.
You can send them back and they'll fix them.
Yeah, they offered that, but they also told me, well, let's just do this and,
Yeah.
okay, it's gonna be quicker.
Yeah, but they will fix broken sensors. If you ship them there, they'll actually ship them back to you fixed. Yeah. So if you have broken sensors, they will fix them.
Yeah, because some of those sensors are like $300-400 a sensor.
I know.
So
Yeah.
after many years, you can build them up and get lab groups, but.
Yeah. Jen actually applied to Painted Hand and got some money from Painted Hand. She bought a bunch of sensors. So, don't want to take her pool of money away, but, yeah. So what, that's a very cool resource. Thanks, Jen, that was
Yeah.
awesome. I mean,
Because like I said, for some of them, like I said, like they'll, like if you, some of them will have like physical actual resources there, like for the Coulomb's law, for example, they have a how-to video. Sometimes they'll have actual like
like document of some kind that somebody at some point has created an actual like document lab for it.
The one had said see resources and then I clicked on it and it's gone.
That's what I'm saying, so there's
Let's just
been
go to-
changes on this
oh,
one
here's
too.
something, yeah.
It just depends,
Lab
right?
sheet,
That's
yeah.
what I'm saying, so some of them do, some of them don't. I mean, ones that I've done that like I actually have stuff for example, there was a 2-part motion one, which is good for kinematics. Where you start off with, and you get a basically double graph, and so part of it's accelerated motion, and then it turns into constant motion, like a dragster. You can change the type of car, but then when it samples, you basically get like position data that the kids have to measure by like looking at like basically like photogate type stuff. But the timestamps are equal, and then you get them to practice their graphing. And there's actually a digital graph program that they have that links to this site. So it's another like quick and dirty that I've used. It's similar to Excel, only even easier, to be quite honest. Let me see if I can figure out tools. There we go. Where it's like even faster. It's a program called Quick Graph that they have, where it's like very fast. I'm gonna steal your computer for a sec. Because if anybody finds this interesting, they actually have a really handy thing in here. Let me find it. Tools. Which I found handy. It's like the same premise as using Excel, only even faster. Because it'll live graph like as they put in the data, kind of like Desmos does, if anybody uses Desmos. And you can do trend lines on there. They're not as accurate as Excel, but it'll still do it. And if Ron's computer's being slow, I'll just plug mine in instead. But it's like really, I find it handy. Oh, it's just hanging. Might be like your Wi-Fi connection because you were doing it differently, remember?
Oh,
So it might be hanging.
yeah.
That's okay. We can do it online instead. It's just as easy.
Yeah, well, really.
At this point, I'm like, oh.
Yeah, it's just plug it in, right?
Uh-huh. So here, so this is the Quick Graph program. It's super fast. You can actually change your X and Y labels for anybody who finds this of any interest. So X, it even says the thing you changed, and then Y is a dependent variable, so you can actually change your labels. So, but like if I just type in some random data like 0, 1, just make this very simple. 4, 5, 6, 7, 8. Let's say we had something that's like a problem to start, like I'll make this super clean. 1, and then it starts graphing the data on the right-hand side immediately. And you can actually toggle on and off some of the data points too, which is kind of cool for this particular program. And then, I don't know, we go linear after that. Let's say linear 11. So I've got something that started off as accelerated and then linear. So right now it's showing like, and I can make this bigger by going here and showing like all of the data bigger on the screen if I wanted. If the circles are red, then it's showing that data for a data fit, but you can go over here and click on the individual numbers and like toggle off the data. So long as, in such a, when the numbers on the left would turn black, then if you're doing like a curve fit, it won't include them. So it'll actually ignore the data. So I could just do a trend line for here, like just the linear part of it. So I deselected the nonlinear, and really this is an overlapping point, so that's technically counts. But you go here to like curve fit, and then you can pick. So proportional forces it to 0, linear is just going to be whatever y equals mx plus b. A squared, a cubed, obviously for physics we're using like proportional, linear, and squared, because like anything else on here we don't use, right? So here I have a straight up linear fit, and then what it'll do, you just click linear, and it'll do the same thing that Excel does, and because I had perfect data, my correlation is going to be exactly 1 to 1, clearly, because I made it nice and clean. So apparently that's line 2x plus 3. But you can then use it, right, because they can screen grab this, they can download this. So I find that it's very handy, because then if the kids are on Chromebooks, you can make them change the titles, and then if I do that, if I go back and I say, okay, I don't know, let's just say this was like a position time graph. So I could say like position, like literally just change it Then you can like mark them, like, did you put units on, right? So this would be like time in seconds, and then here, and then it'll live change the axis labels too. Like meters. So let's say there's a position time graph, and so it'll automatically label it. So even if you want to mark kids on a graph for labels, like, and it's all like quick and dirty, totally free. And they just dump the data in. So even for the lab that we just did, right, when we were doing like, if the kids say had to do the calculations by hand in a table, they could then dump in the final data values and do the same trend fitting here if you wanted something a little less, if you didn't want to try and figure out like all the details and like, yes, they'd have to calculate the numbers versus putting a formula in, but you could still get them to do a quick digital graph without them potentially needing to learn the ins and outs of like Excel, right? This will do the same, I would argue, for like the detail we need and want. I would argue we could probably get the same kind of results. And here, if you wanted stuff with like exponentials, you have to type like the E plus 14, like for them. So it can do it here too. You just have to do the formatting correctly. So, and I've used this for a lot of stuff in like what was physics 11 and 12 where I was. Like it's really quick and dirty. Kids can like screen grab and print if you wanted, or if you're doing it digital, they can screen grab and add it to a digital Google Doc. Or so I've done both. So, and then obviously like, you know, if you're wanting it to fit or not fit, right? So just another tool that's available as we're potentially, if we're trying to do more digital stuff. And this is part of Physics Aviaries. Like that's where the links to is that Physics Aviary page. So I found these to be pretty user friendly. Like obviously I have no clue what equipment you guys have available at your schools. Obviously I suspect the regional is gonna have stuff similar to us because they're bigger. Esther Hazy, same idea because they're bigger, right? But obviously our smaller school has right? So in terms of what there is, I mean, obviously I realize that we kind of set this up to be focused on modern physics because that is one of the harder ones for us to do. But I mean, for anybody else who's new, is there anything else that like we can potentially, like that you're thinking of, wanting to do, possibly wanting to do, had trouble doing, like lab-wise, that's kind of coming to mind based on what you know you have, like, or anybody who hasn't taught it yet, obviously you're probably not even sure what to think. So I respect that too. But like this program is fairly versatile. I've obviously got tons of, like, I have a lot of resources from Ontario because I have been doing this for a while too, just not here, but same stuff, just a different moment.
have to leave in a few minutes.
Yeah, we can probably clean it up.
But yeah,
If you
there's
just click on stop streaming when you're
a lot of stuff that we can do.
We can probably clean it up now if we want. Or you want to
Emission
obviously go with
spectra.
Main thing is to
I've
show
done the
that
energy loss and a bounce one
keep going
before
forward.
as a way of talking about efficiency.
Otherwise, I clean it up tomorrow.
So that one's an easy one, where you
okay.
just look like MGH versus kinetic energy for your energy unit.
You're just sharing some
And look
stuff.
at efficiency, and then it gives you different types of balls, like in terms of like other units where we can do stuff. So this is another easy
Just
one.
tell Lisa we're gonna shut down the stream. Lisa, we're gonna shut down the stream, so Dawn has to clean up, so hope you got something out of this. Take care.
And so you